Good morning, sir.
Good morning.
So shall we start from 10 a.m.? The
Yeah.
participants are joining.
Sure. I'll be here only.
Sir, I've made it a presenter.
Okay.
Okay, thank you so much, sir.
Yeah.
A very good morning to all present here. I welcome you all on the second day of our 1 week ATAL FDP on Foundation of Data Science and its Applications Advanced. Today, we will have 3 sessions. In the first session, we have Dr. Ashish from IIIT Gandhinagar to enlighten us on the topic of medical image denoising. He's working as an assistant professor in the Department of Computer Science and Engineering at IIIT Gandhinagar campus. He received his MTech degree and PhD degree from Dhirubhai Ambani Institute of Information and Communication Technology in 2010 and 2016 respectively. He is a life member of IUPRAI and a member of esteemed societies like Signal Processing Society and Computational Intelligence Society. His area of interest includes image processing, pattern recognition, soft computing, and medical image analysis. He has published over 25 research papers in reputed international journals and international conferences. Sir, I welcome you. Thank you for joining us here. Shall we begin with your presentation, sir?
Yeah, thank you for introduction. I think my slides are visible in the full screen mode.
Yes, sir. Your slides are visible. We really look forward to learning from you, sir.
Yeah, so are we good to go ahead if participants are there?
Definitely, sir. They are increasing. Right now, they're 56 in number and they're quickly increasing.
Okay, sure. So we can start now then. Okay, so good morning to all participants, and let's have some interactive session on my work in 3D MRI denoising for medical image analysis purpose. So this is my email address. In case if we may not discuss much during the session, you can feel free to drop an email to my email address and we can take offline discussion if you are interested. Okay. So let's talk about what is a noise in the image and why we require a denoising and all kind of pre-processing for medical purpose. Okay. So take a look at this image which I have taken during my work from a mobile camera, which you can see there is a very noisy in the background because you can't see the background and you see some dots, colorful dots in the image, which we say, okay, quality of image is not good. We need some better quality image. So the purpose of denoising is to improvise the quality of image given the devices we have. Okay, so it's not required that you always go for a high-end devices to get a better quality image. There may be some restriction over there because in case of medical imaging, device cost is quite high, so you cannot have a high quality devices every time. Okay, so what happens in case of images in medical domain when a patient goes for scanning, there may be some issues like in case of MRI, a patient has to stay there on the bed for almost 20 to 25 minutes for completion of one scan. Okay, and in case of elderly patients, you cannot have another round of scanning for another half an hour. Okay, so in such cases, once patient scan is done, we can implement some pre-processing tasks to improvise the quality of image. Similarly, in X-ray scanning, we have a exposure of X-ray rays to human body, and multiple exposures may affect some of the functioning of human body. So in such cases, we cannot expose multiple times uh, under such conditions. So we need to improvise the quality of image by doing some pre-processing on the software side, kind of that. Okay. So for analysis purpose, what we do in case of medical imaging or in general image processing, what we have is we consider an image IX, which is a original image or a true scene, which we can see from our eyes. Okay, and then there is some noisy environment is added up when we capture an image, and what we get as an output of clicking a photo or having a scan is that we get I of n, which is representation of noisy image. Okay. So most of the time we get this in, which is the right side quantity, and we don't have either of I of x, and also we don't know most of the time what is the noise condition or noise environment. Okay. In image processing, we consider noise as an additional component. We consider sometimes motion blur, other type of blurs also as a additional component which get added up with the images. Okay, so for that we have a similar kind of equation with sophisticated terms to be get added up based on the environment in which image is captured or image is acquired. So for simulation purpose, what we do is uh, we take an original image for simulation. We generate a random noise by using a random number generators, and then we add up and we get a noisy image which is on the right side. Okay. Now our task is we use this noisy image which is our observed data on the right hand side, and we try to estimate the original image, okay, and the noise component, okay, or noise quantity or amount by which the image get uh, corrupted. Okay, so that makes our problem is somewhat ill-posed because we have only one quantity which is on the right hand side, in or noisy image, and we have to estimate two quantities, which is one is original image and second one is noise quantity. Okay, because these both are essential for further analysis. So that makes a life a bit problematic because we have like one equation and two unknowns in simple terms. So that becomes a ill-posed problem in mathematical terms. Okay, and for medical images, this is for simulation purpose. But in case of medical images, the life becomes more problematic because over there we don't have a true scene most of the time. Okay, because when you have a scan done, we get only scan image and we try to find out what is going to be original image and how much noise component is over there. So this is the how we do simulation to estimate whether our algorithm is doing well or not, and then we can hook up it on the original images. So in most of the cases, we assume in natural image processing, we assume that our noise is Gaussian or following a Gaussian distribution with zero mean and sigma as a standard deviation. Okay, so zero means is because it should not take average value of image to another level. Only it just changing by sigma. Okay, values are just get away from fewer values, not in terms of average. Okay, so that's a inherent assumption for any image denoising problem. In case of natural images, when you talk about image denoising, we in general assume they are following a Gaussian distribution. And another thing for Gaussian is it's a very simple to deal with. Okay, we get a correctable solution in analytical terms for Gaussian distribution, so that helps to achieve a optimized solution. So that makes life simpler in terms of computational feasibility. But in medical and other domains, so in medical domain, we'll discuss what kind of noise it is. But like for astronomical images, noise is different than medical than Gaussian. Okay, so people have studied the nature of environment or image acquisition process to understand how noise get added up. Okay, so that way we can create a more sophisticated algorithms for particular problems. Okay, instead of always assuming noise is Gaussian in nature. So most of the talk is based on our paper from Medical Resonance Imaging Journal, published in 2017, and we'll discuss what are the upcoming things which are there in the domain. So here is the first question: how noise is generated in MRI image acquisition? So what I said, the patient has to lie down on the bed, and it's a huge machine, and one scan takes 20 to 25 minutes for scanning. Okay, and during that time there is a blood circulation, patient is breathing, so such things get acquired. Even a small motion is also being done by patient. It is expected because you can't stay still for 20 minutes. Okay, if you are unconscious. If you are conscious, so you can't uh, remain still for 20 minutes in the same position. Okay, so there is some motion get acquired. So and also there may be some device issues like because there is electronic circuitry, magnetic field is there, so there may be some heat generated, and because of heat or thermal noise, uh, image get kept, corrupted, because the signals that we receive is MRI signal or complex domain signal, and for converting those complex domain signals, we use FFT translation to get a real image or image intensity values. Okay, so during that transformation, signal values also get corrupted in that way. Okay, so there are multiple sources that come up to make image a corrupt image. So here is the distribution, which is called as Rice distribution, which is actually playing a role in medical images. So Rice distribution having a two component, one is real, another one is imaginary. Okay, and it's belongs to the same family of Gaussian distribution. We call them as a family of exponential distribution, where exponential, Poisson, Riccian, Gaussian, all are the part of the same family of distribution, and their distribution looks like similar. So this is the equation for Rice distribution, where you can see an exponential component. I0 is a Bessel function which is coming up because of transformation of a signal to a real image. Okay, so over there we deploy inverse FFT, and then we get this signal. So this is how reshape distribution looks like. And to get an actual real image from imaginary and real component, we take a square of individual values and then square root. So that gives a value of intensity in the image. And to estimate unbiased estimation for the corrupted value, we do m square minus 2 of sigma square as an estimator. But remember, sigma is a representation of noise quantity. Okay, and that also we have to estimate to find out the unbiased estimator of our signal if we want to denoise. Okay, so we need a true signal or estimated signal and then estimated noise also. And for this distribution, if signal to noise ratio is very high, it means your signal quality is very high and noise quantity is very low. In that case, if SNR is very high, this distribution actually behaves like a Gaussian distribution. So there is very similarity with Gaussian for this distribution. Another condition is if signal is zero, then this distribution becomes Rayleigh distribution. Okay, so this distribution is having a combination of these two. If SNR is very high, it becomes a Gaussian distribution, And if SNR is 0, it means signal is 0, it becomes real-line distribution. So depending on the SNR values, we have to check how our signals behave over there. And this has been proven in the paper in 1995 that how research distribution is get acquired during the acquisition process of an MRI. So from that, people started working with rice distribution if you want to work with medical image denoising problem. So what we do for simulation purpose, how we can generate a rice distribution. So we do it using a Gaussian distribution. So assume that I0 is our original signal, okay, and we add a noise component which is zero mean and sigma value, okay, which is over here. So we add a noise in the original signal, okay, that we call it as a real signal. And for imagery, we assume that there is no signal available right now, and we just add a noise component, okay. Again with zero mean and sigma value. Right now we consider both the channel. Real imagery has the same noise values or noise quantity. We can also change the values, but then life becomes more difficult if we have sigma 1 in the real component, sigma 2 in the imaginary component. Okay, so we generate two channels for the price distribution, and then we create a signal using this square root and squaring both the components. Okay, so this becomes a reshape distributed image or reshape distributed corrupted image or noisy image, I of Rn over here. Now our task is to estimate this I0 signal again and the noise component, which is sigma over here in both the channels. Okay, so here is the convention that we follow as a part of community, that if I say there is a 3% rise distribution, okay, so this is how we can convert this percentage into a noise value. So this is your sigma in the rise distribution. So rise distribution is actually a more stronger noise. Stronger means it corrupts signal more than the Gaussian noise. Okay, if for example my signal values 10, Gaussian distribution or Gaussian noise can make it 9 or 8, but rise may make it 6 or 7. Okay, so it's more denser in terms of affecting the signal. So take a look on this one. So the left image is a synthetic image which we generated as a ground truth image or I0 image. Now the second one is a Gaussian noise which is affected with sigma equals to 5. Okay, so over here it is sigma square is 25, so sigma is 5, and then this noisy image has a PSNR value is 35.8 approximately. But at the same quantity of noise, where sigma is 5, this is reshaped this corrupted noisy image, which is has a PSNR is 32.5. Okay, so there is a shift of 3 dB PSNR. Okay, and I hope majority of participants are from electronics background. So shift of 3 dB is huge. Okay, so it means your signal is corrupted more because of price distribution, and there are two noisy components playing role in the rice distribution. Okay, so this is how things takes place when we have MRI scan. Anyone, any queries so far till this point?
So till now, we have not received any query. In case if the participants have any queries, they will post in the chat box and I will definitely answer them.
Okay, sure. Okay.
Thank you, sir.
Okay, so let's go ahead and let's talk about some of the well-known quality measures that whether our algorithm is working well or not. So in medical domain, we don't have ground truth most of the time. Okay, so what we do is we simulate our algorithm by taking, assuming that image is noise free, we add a noise, and then we denoise, and then we compare the original signal with our estimated signal. Okay, so for that there are few well-known quality measures. First one is PSNR, peak signal to noise ratio. It's very simple in calculation, and by looking at the values, we can compare. Higher the value is better the approach. Second one is called Q index, which is not, which is having a combination of three component: correlation coefficient, luminance distortion, contrast distortion for every patch of an image, and it gets computed for all the patches. For example, image is divided into 8 by 8 patch, and then for each patch we calculate Q value given the two images, and then you take an average of all the patch values which will be for an image. Okay, so essentially we generate a map of values, and then we take the average value for as a single value for the whole image. But later on, it has been revised with the called SSIM, Structure Similarity Index measure, which is well known and well established measure for all sorts of image processing applications. Again, SSIM is based on these three components of Q index because it was published by same authors, I guess. Yeah, part of same authors with few additional authors, and it has been taken care with some power values like alpha, beta, gamma, and they have defined the values like SSI value between image X and image Y is same as SSI between Y and X. SSI value will be maximum 1 and it will be less than 1. And if signals are same, so SSI value has to be 1. Okay, and then they have taken a few mathematical corrections to ensure that there is division by zero should not happen. So they added some constants C1, C2, C3, and done some mathematical calculation, and then they came up with this formula which is highlighted. So again, SSIM is because based on Q index, so it's calculated on image patches. Okay, so we create a patch of like 8 cross 8 in both the images, and we compare, and we get a patch value for SSIM. So it gives a SSIM map, image map over there, and you take average value of all the patch values of SSIM, and you just average, you will get mean SSIM value for a image between X and Y. Okay, so this will be one value. If you take SSIM simply X comma Y, you will get between the patches for the whole both the images. Okay, patch by patch comparison. Then another measure is based on the feature values. Again, it follows the same notion that it's comparing the two patches in the images respect on the respective positions, and then you get a map, and then you just average out to get a one value for both the images. Okay, so in all the measures we assume one is ground truth and another image is our estimated value or estimated image. Next one is called method noise, which is simply a subtraction between a noisy image and denoised image. Okay, so what this says is if is my pointer is visible what I'm writing.
Yes, sir, it is visible.
Okay, okay, so this is the formula that we started with. Okay, so if our image is noisy uh, and assuming that it is additive Gaussian noise, so we started with this formula. Now, what we do, we just subtract these two quantities. So over here, what we do is we have this one, I of x and I naught hat, okay, which is our estimated value, okay, which is we can assume that these two are equivalent, okay. If we subtract these two, we are going to have only noise component, okay, assuming that our algorithm is giving I naught as perfect as possible or as close as to original I naught, and then if we subtract we will get only noise component which is over here. Okay, so by looking at the noise component, the idea is it should be looks like random. If you see any image structure or edge structures in the noisy signal or noisy image in this one, we can say still noise is affecting our edges. Okay, so idea is if we get this noise component, it should be random in nature. There should not be any edges present from the images. Okay. So these are the few methods to compare various approaches and the new one which we coming up. Okay, so these are the measures to compare the efficiency of algorithms, and these are well established and well accepted measures. Now let's talk about the image denoising approaches which are existing. So we can classify approaches on different aspects. So one is called diffusion based, where we talk about the concepts oriented from differential equations or physics. Okay, so diffusion based are partial derivative domain based. So first one is isotropic diffusion, which was the one of the oldest method for image denoising. Then anisotropic method, which has a much better improvisation than isotropic. And this anisotropic is led by Perona-Malik method, then Picard's method, robust anisotropic, probabilistic anisotropic. So these all are methods based on the differential equations, and we solve a range of equations to get the noise-free values, and hoping that the noise will be removed over there. Second set of methods are based on the comparing image patches between within the image. So for that, few simple methods are mean and median filter, then bilateral filter proposed in 1998. Then few variants of bilateral came up in the community, and then one of the famous called non-local means, which we discuss later on in detail, came in 2005, and then people started coming up with different variants of non-local means method over there based on the success achieved by NLM. Okay, so NLM was one of the this generation method which pioneered again image denoising in a different orientation. Then few dictionary-based methods came up in the community which are based on wavelength domain, singular value decomposition, and then this the last one is BM3D, block matching 3D, which is another pioneering method came in 2008, which revolutionized the notion of image denoising, and it was much better than non-local means. Then few methods which uses statistical analysis, which are based on Gaussian mixture model, Markov random field, game theory, fuzzy logic. So they use statistical properties to remove the noises and preserving the image structures over there. And then a few hybrid methods which take combinations of either of them. And so this is just a broad classifications to give you an idea that, what categories of methods are there, and we'll discuss few of them in the coming slides. So simple is the which is early age denoising methods are based on transformation domain. So we assume that this is our model, and then we apply orthonormal basis to transform the image, and then for that we use like Fourier transformation, DCT, discrete cosine wavelength, or any other orthonormal basis. There are thousands of bases available, but you have to check with orthonormal only, because once you transform the signal to another domain, because image denoising is the problem where you look forward to an image which is noise free. Okay, so from noises or from image domain you goes to signal domain or transform domain, but you have to come back to the image domain. Okay, so your basis has to be orthonormal so that they can preserve the property of or structures of images. So remember, if you apply any orthonorm any transformation, it has to be orthonormal in the nature so that you can get your result back into image space. Okay, so what happens in transform domain is you convert image intensity values to signal values or transform domain values, and over there we cut down the few values based on the properties of every domain. We cut down few values, and then we again apply inverse transformation. Okay, so over there once you apply inverse you will get the image space back. Okay, And then few are the methods based on the properties of global structure of image, and few are based on the local structure of images. Okay, so there are few methods which actually works well in the transformation domain. So like hard thresholding. If your signal, once you transform from image to apply a transformation, and if value is higher than some threshold, you just make it 1, and otherwise you make it 0. Okay, so assuming that the below threshold values are correspond to noise signal, you just transform. Okay, similarly there is a soft thresholding method, because hard thresholding makes signal binary, so you make some minor changes, become soft thresholding, and then you try to preserve better structure of the images in the transform domain. And then Wiener filter is another variation where you preserve the signal or structure of image given the noise quantity. So for Wiener filter, we need to know what is the sigma value of the noise which is corrupted, which is corrupting our signal. Okay, so let's talk about the non-local means method, where uh, what happens in the image is, in most of the cases, we have a portion of image which is present over there in a large space. Okay, so like if we look at the patches which are colorful in nature, so like red color patches which are similar to each other. Similarly, yellow color patches are similar in each other with respect to intensity. Similarly, green color which are available on different places. Okay, so they are similar to each other. And then orange color which are correspond to grass structure, and then again this blue color which are correspond to some pillar structure. So there are several places where patches may be similar to each other. Okay, so idea of non-local self similarity is, can we find out similar patches which are not close by? Non-local means they are not close by in image space, and they are self-similar, means they are similar to each other. Can we find out such patches, and can we use this information in image denoising? Okay, so here is an example that if you look at this Lena image, so there is lots of text just for uh, completion of talk, but let me explain you in a simple terms. Look at this patch P, which is I'm highlighting over here. For this patch, we want to denoise this patch. Okay, so now in context of non-local means, we have to see similar patches which are there. Okay, so we can find out a patch Q1 which maybe looks like similar. Similarly, patch Q2 which maybe looks like similar. Okay, so we are going to use a weight function between patch P and Q1 and between patch P and Q2. Okay, since we are saying the weight there looks like same, so their weight has to be high then compared to a patch which is completely different than the patch P. Okay, so if I have a patch Q3, so weight between P and Q3 should be very lower than weight between patch P and Q1 and patch P and Q2. Okay, so what we do, we compare intensity values or difference between intensity values between the patches. Okay, Ni is the patch I and Nj is the neighborhood of patch I. Okay, so between these two patches we compare, and then we take a exponential decay function, okay, to give the weights. The values or patches which are very close, these weights will be very high between I and j. If patches are different or patch I and j are different, then this weight will be very less or it will keep on decaying. Okay, so this is like going to be like this. So this is your difference value which is over here. This is your d value, and if d is going high, your weight value will be going down. Okay, so it's a kind of an weighted average method. What we do in the simple mean filtering, we just take sum of values and divide by the number of samples, This is a more intuitive way to create a weights between the patches. Okay, so then for denoising any patch I, we take a weighted average of all the patches with respect to I. Okay, so J is the neighborhood of the patch I. Okay, and then we take average value over there. So non-local means for every patch we compare each and every patch and we compute the weights. Okay, if weight is high, so patches will play a role for denoising. If weight is low, their effect will goes down. Okay, so essentially what happens is if I number down patches 1, 2, 3, 4, 5, 6, so on in the image. So for denoising patch 1, okay, what we are going to do is we are going to have W2 I2 or patch I2 plus W3 patch 3 plus W4 patch 4 and so on. Okay, so we define weights over here for denoising patch 1. Similarly for patch 2 there will be another equation with similar weights. So weights will be calculated based on how patch 2 looks like. But computationally, this method is very time consuming. Okay, and if I have an image of 100 cross 100, it will be okay. But if we have an image of 512 by 512, so this computation will be very high. So what authors have proposed is a search window where you search the similar patches in a sufficiently large window around the patches where we want to perform a denoising. Okay. So in the previous slide, what we can do is, so if we have to denoise patch P, so we can consider a bigger window like this one, which I am drawing right now. So you search for similar patches in this window and perform the task of denoising. Okay, so that will restrict the computationally uh, the approach. Okay, but that will be not non-local because there may be other areas of the images, other area of image where the similar patches may be present. Okay, but we are restricting because otherwise your method will be more computationally intensive and you require high computational resources for perform denoising. So then few people came up with the different variants. One is called rotationally invariant because there may be the cases where patches may be rotationally variant of each other. Okay, so like the left image, you see patches on the left corner of the structure of the muffler, and there are multiple corners possible which are rotationally similar. Okay, if we rotate the candidate patch, there may be different versions available. So can we take such structures into the configuration? Okay, so they came up with the variation like rotationally invariant matching. Second one, where the moment is there, which is statistical moments, which also used to define the properties of image patch. So can we have those structure or similarity measure between for configuration? Because the question is how we define similarity between the patches. Is it only a difference between intensity values? It is based on the structure or what else? So can we exploit the similarity in different ways? So that's the major area of research where people actually work upon how we can define similarity. For one, similarity definition may be different. One, another may have a different notion of similarity. Okay. Similarly, like the last one, they have defined SSIM measure value for defining NLM approach. Okay, so they compare SSIM value for two patches. If SSIM value is very high, they consider that as a similar. Otherwise, they are dissimilar patches. So all three methods at least are like how we define similarity definition in the approach. Okay, other than the proposed one. This one is for BM3D method, which came in 2007 over here, which is an idea of non-local means, but they are using collaborative filtering approach to perform denoising. Okay, so this is proposed as a two-step method where they collect the patches which are similar to patch R, which is colored over here. Okay, so they take non-local self-similar patches. They make a structure of cube like this one, and they take a 3D transformation. Now this is like sketch representation. Now they perform 3D transformation, perform hard thresholding to cut down the noise signal. Then they perform inverse 3D transformation to get the image space back, and then they perform aggregation. Okay, so this is step one. Similarly, so by step one, there will be some noise component will be which will be get removed, but then they perform another equation in the similar motion, and then they get the finally the output as denoise version. Okay, so this is two-step method which perform on the 3D transformation. Okay, so over here the definition is based on the non-similarity, like a difference between the patch intensity values. But once they get similar patches, they perform 3D transformations and then hard thresholding, then up reverse inverse the domain, and then they get back to the image space. Okay, so major difference over here is in the first step they apply hard thresholding. In the second step they apply Wiener filtering. Okay, so then uh, they get a better result as a denoise image. Okay, similarly, people have also applied for different transformations because over there, BM3D authors have applied 2D DCT and 1D Haar wavelength as a combination of 3D transformation over there. People have applied different transformations over there. Okay, now there are methods which are actually looking for similarity. So the complete research is lying down to find out how we can define similarity. Okay, and then how we make an approach which is truly non-local. Okay, because you otherwise you are restricting your search space to a closer space which is not acceptable. So there are the methods which actually doing a clustering of image patches to find out similar patches, and such methods are, one method is flow which is based on the k-means algorithm. Second method is KD tree approach. Third method is KNN based approach, which they do a clustering of the patches, and then they find out a similarity between the patches. Okay, so idea is once you get a cluster, hopefully the patches which are lying down in the cluster are similar to each other. Okay, given the noise condition. So we worked on the called rough set theory, which is a cousin of fuzzy logic. I'll just give you a brief overview of what is rough set theory in the coming slides, but I hope many of you have comfortable with fuzzy logic. Or meanwhile, if anyone has a query so far, maybe a couple of queries we can discuss.
I request all the participants to please post their query in the chat box, or they can raise their hands. I can unmute them and they can directly ask their questions.
If no queries, then there are two possibilities: either everything is understood or nothing is understood. Okay.
I really that everything is clear. We can carry on. As the questions come, I will.
Sure, sure.
Thank you, sir. So we have one query from Dr. Sachin Kumar. So please tell the KNN method.
KNN.
KNN method.
Okay, KNN is one of the simplest method which is based on the notion to find out k nearest neighbor. So the full form is k nearest neighbor. Nearest is the again a question how we define nearness between two samples. Okay, so if I have one point over here and one point is over here, so we usually use Euclidean distance. Okay, we calculate we know the formula of Euclidean distance, that between point x1 and x2, what is the distance? Okay, so now if it is there is x3, so now what is the difference between x1 and x3? Okay, so if I have to classify x1 to some points, so if I have multiple points, so what are the k nearest neighbors? If I have k as 3, so what are the 3 nearest neighbor for point x1, and what are the classes for those? Based on that, we will assign the class for x1. Okay, for example, if I have two classes like this one is represented as a triangle, another one is represented as circle. Okay, now I have a point which is x1 over here. Now, what are the three closest neighbor for this one? Whether two are from triangle and one is from circle, all three are from triangle, all three are from circle. Based on that, we will assign either triangle or circle as a class. Okay, so that's the idea of KNN.
Thank you, sir, for answering the question. We have another query from Dr. Jitendra Kumar. Sir, how can we use deep learning approach to detect noisy image? Can we use ResNet algorithm here to detect noisy images?
Uh, Dr. Jitendra, we will discuss this point in the last. You please remind me that time. We will definitely discuss this point. I have some
Definitely, sir.
slides over there on deep learning approaches.
Okay, sure. Thank you, sir.
Okay, so then let me go ahead and we'll discuss other domains also. Now, so let me give you a brief idea what we did as a part of this work using rough set theory. So what rough set theory is, it's more like a cousin of fuzzy logic and soft computing approach. It is based on the notion of granularity, which was proposed by Pavlov in 1980s. The idea is, if given a space, if we can divide the space as a part of granules, like a knowledge blocks, okay, and then based on the property, can we define the similarity between those properties? Okay, like in fuzzy logic, we define the membership value as mu as either 0 or 1. Okay, whether your membership value is 0 or 1. But over here, we define based on the property whether our patch is having similar representation or is on the boundary or it does not have a similar representation. Okay, so we define inner approximation which has based on the property B, can we have this complete granule is the same with respect to property B. So consider that an image, okay, my image is divided into patches. So for example, my image is of size 100 cross 100 and my patches are of 8 cross 8, which we divided. Okay, so all these are 8 cross 8 patches. Now my property B can be a simple property of like intensity values. So can these 64 values are in the same range or are the same? Okay, so I highlighted that as a yellow color. Okay, so this is based on the intensity value as B, they are same. Okay, and then what happens if there is an edge? So this is one object represented as circle, and another outside this object boundary, there is another set of values. Okay, so based on the properties, so white color is something which is not part of object, but these orange color boxes or patches are patches which are possibly part of the object. Yellow color is surely part of object like membership value as one, but these orange color boxes are partially part of object. Okay, so what we define is one is called inner approximation in terms of rough set theory. Another one is upper approximation, which is boundary region and the inner approximation. Okay, if we subtract upper and inner, then we get boundary area. Okay, so we define using entropy, we define what are the patches which are part of an object, which are not part of an object. Okay, so this is one way to segregate the similar looking patches and non-similar patches. Okay, so over here our definition of similarity slightly changes than the what others have done. And then rucksack theory also been used for some of the problems in the medical domain for partial volume effect and finding out the using GMM also, then region of interest in the medical domain. So rucksack has been also used as a part. So from that, in our another work, we define the two approaches using rough set theory. One is called rough set based class labels and rough set based age band. Okay, so we use those two approaches over here. And another thing, what we discussed is the medical images as rights distribution. So assuming a simple Gaussian based approaches or Gaussian distribution noise won't help. Okay, so simply applying a PCA is not going to help. Okay, because PCA has inherent assumption of that data is following a Gaussian distribution. So what we did is we tried a kernel PCA, kernelization. Okay, so which is uh, soul of SVM. Those who know support vector machine, they must have gone through the VP theory. Okay, VC theory. Sorry. Okay, so because the idea is for high dimensional data, sometimes we may not get non-linear boundaries. Okay, so we transform our data to another space and which is called kernel trick, and then we use the algorithm over there, classification or clustering, and then we come back. Okay, so we apply a kernel trick over here. So like you transform the data to another space. Okay, and this is the problem, and we solve eigenvalue problem in the transform domain, and these are the commonly used kernels. Okay, so those who work with the SVM, they might have used polynomial kernel, Gaussian kernel, or RBF kernel, hyperbolic kernel. There are other kernels available for SVM. Otherwise, you simply transform the data and then we perform the approach. So we use KPCA over here like this one. So the left side is our data in two dimensional x1 and x2. So each point has x1 coordinate value, x2 coordinate value, but you can't find a linear separation between these two. Okay. So in this case, it is very difficult for linear separation. So what we can do is we transform this data x1, x2 from two dimension to three dimension. Okay, so then this is one transformation approach is applied where first coordinate kept as it is, second one as it is, third one is x1 square plus x2 square. Now, if you look at 3D representation, now what we can do is over here we can easily, sorry, we can have a classification as a plane. So there may be we can construct a separating hyperplane or a 2D plane from this class to upper class. Okay, so red and blue color classes we can separate out in three dimensional as a linear hyperplane. Okay, which is not possible in the two dimensional. So this way we can perform a task if your data is not well separated or linearly separated. Okay. So we did some simulation work to see how PCA and KPCA works on the region distributed data. Okay. So these are the few just to find out what are the basis vector for PCA. So the left one is left top is synthetic data which we generated. Then the right one is the region noise is again. Then we applied PCA on this region distributed data. So PCA gives different orientations, but kernel PCA gives a similar orientation. So you can see our data is right side aligned, but PCA gives left alignment, but kernel PCA preserves the alignment. Okay, so that was the idea to show how kernel PCA works. So we use this approach to find out the or performing denoising. Okay, so this was our the architecture or structure. We use a complete volume of 3D image and we define the cubes of size P cross P cross P. Just a second, everyone. Okay, sorry for that. So what we do is we take a cube instead of a patch. Now we take a 3D cube of size P cross P cross P from the image, and we convert into a giga matrix. Okay, so we just convert into 2D matrix. We apply kernel matrix split, transform the giga into higher dimension, and then we apply PCA over there, or kernel PCA, and then we perform hard thresholding in the domain, in the KPC domain. We perform inverse projection, and we perform bias correction because there is a bias field there in the medical image, and then we get the image back, which is filtered image or a filtered volume over there, which is denoise version. Okay, so this was the approach, and for this we perform, uh, we use the few ideas that we had in the previous work called rough edge map and classes, which was based on the rough set theory, and then we form a cluster using those rough set notion. So we have a cluster so that we can get the similar patches together. We perform KPCA for each cluster because they are similar, hopefully similar in the nature. So for each cluster, we perform KPCA. We perform uh, projection of basis. We modify the coefficient using hard thresholding, and we do the inverse mapping, and then we get the denoise image. Okay, so this was the idea of our class, and then we perform few comparisons with the well-known methods with the different modalities of MRI. So here are the results. Simply, I'll just go through. Those who are interested, they can take a look on the paper, and we can discuss otherwise. So we use like four measures. One is PSNR, RMSE, mean SSIM, and then FSIM measures with the few on the images, like how it is working on the 2D images, and then how it is working on the 3D images. So there are four methods that we compared with. Like one is over NLM, which for applied for a 3D way on using NLM concept. Then ABO NLM, then UKR method, then BM4D. BM4D is the variant of BM3D for 3D images. Okay, so we use different kernels. We tried different kernels, and these are the just comparisons between based on the few measures, like how it is working. Okay, sorry, I missed out a point. So this method, this table 2 is representing for a noise-free data. What we did is just to check whether kernel PCA is preserving the structure or not. So what will happen if my denoising algorithm is working on the noise-free image? If it is noise-free, the idea is algorithm should not do anything with the image. It should preserve the structure. Okay, so what we did is, so we gave it a noise-free image and input to algorithm, and we got some value or image, and then we compared how much distortion is occurred during the processing. Okay, so you can see for PRA NLM approach, PSNR is 12. For UKR, it is 12. BM4 it is 47. Means it is preserving more structure than other two methods. But kernel PCA based approach is preserving with a PSNR of 200. Okay, which is quite high. And similarly, SSIM value is exactly 1. It means kernel PCA or our approach is not distortion, not distorting any structure of the image if we give a noise-free version or noise-free image over there. So that was the idea, to show how algorithm is working if there is no noise at all. So in that case, it should not change a structure much. And then we did a few noise measures over there with the methods. with different noise levels with like intensity 5, can 15, 25, and so on. This is on the another T2 modality where we have different noise levels, and then we highlighted the best figures in the bowl. Then this is another one on T1. This is on T2 on different data set. Okay, so this was our work majorly what we discussed so far. Now there are few pointers that I will hook up for others to take forward. So one is what will happen if Gaussian does not hold. So one, we have seen in the medical there is a Rice distribution which is having a different structures. So that is one case that you deploy a method which can deal with the Rice Richer noise. Okay, so we use kernel PCA in our work. Now there are other possibilities that Gaussian noise may not be there. So this is our model that we assume first is noise is additive. It just get added with the intensity value or get subtracted with the intensity value. So if your intensity value is 100, you may get 105 or 95 somewhere. Okay, and then that will be your noisy version. And we assume that the distribution is Gaussian in nature. Okay, so these two are the inherent assumption for this model because this model is very simple to use. Okay, but what will happen if this does not hold true? Okay, so there are cases when noise is multiplicative, noise is signal dependent. Okay, and noise is especially dependent. Okay, so and distribution also changes. So it may not be poison, it may not be it may be poison, it may be rice, which we have seen, it may be binomial or some other. Okay, so there are few heuristic approaches that has been proposed in the literature. So one is multiplicative noise. So this happens, multiplicative noise happens mostly in case of astronomical images. Okay. So noise model is represented as Ix multiplied with Nika noise value. Okay, so when we had a addition over here, so it was like your image changes from 100 to 105 or 95. But now it may be multiplied by a factor 2, so 100 will become 200, which is quite large variation. Okay, so what happens in such cases? We take a log. Okay, so we transform this image into log function or log domain. So now this becomes additive in nature. Okay, so that makes our life much simpler, and then we can apply anti-log to get the original values back. Okay, so this is one approach we can do. Another one is called Anacom's transformation or variance stabilization method. Okay, it was proposed in 1948. Anacom's transformation. So the idea is that you transform any data to approximately standard Gaussian data. So there are functional forms which can apply to non-Gaussian data to make it Gaussian. So in case of Poisson noise, if your data X is Poisson noise distributed, this is the transformation. You apply 2 square root x plus 3 by 8. Okay, so that is a computation, and this data will be your standard normal distribution on the right hand side. Okay, so this is the functional representation. Similarly, if your data is Retian, then this is the transformation derived by Foy in 2011, that your x is your Retian distributed data, and then you apply this transformation like this one. And sigma is your noise value, noise component that we discussed in the beginning. So this will make you your data to standard Gaussian distribution from the Retian distribution. There is a another case when the noise is signal dependent. So depending on the signal values, your noise is affected. So in that case, Poison PDF is there. So what we can do is we can apply Anacon's transformation first. Your signal will become Gaussian distributed. Then you apply any method, denoising method, which is Gaussian distributed, and then you perform the inverse transformation. Similarly, BM4D method is using this transformation, Anacon's transformation. So what they do is they apply this Anacon's transformation first. Giga becomes standard Gaussian normal, and then they perform BM3D, and then they do the inverse mapping. Then there is another denoising area which is called multi-model, where you have multiple images available for same scene or same structure. Okay, so that is very much common in MRI case, where MRI has 3 to 4 modalities easily available, which is called T1, T2, proton density, then flare, then spec. So all these are based on the physical properties, how image is acquired. So based on that, so at the same scan type, we get multiple modalities together. Okay, so over there, what we can do is for same scene, we get multiple images. So can we use those informations together for performing denoising? Okay, so that's the idea of multi-model denoising. In natural images, it may be considered as a flash image, non-flash image. Okay, so you can see two different structures over there, where intensity is very low in the flash image, and in non-flash it may be very high. Okay, so can we use these two images which is available with us, and can we use them for denoising? Okay, so for medical it is T1 and T2. So if you look at T1 images, intensity range is between 0 to 150 typically. However, in T2 it will be 0 to 255. Okay, and can we use because boundaries are more uh, having a different intensity values over here in the T2, we get a better idea compared to T1. So can we use those things? So here are a few approaches which came in the literature. First one is called cross or joint bilateral filter. So so what we do is we perform denoising in one image by taking input of structure from another image. Okay. So for example, if I have to denoise T1 image, we will use the structure of T2 image into consideration. Okay, so that will define our notion of similarity. Okay, so this is the formulation that again kind of a weighted average. So this is difference between patch P and Q. Okay, and then we take a structure of patches in P, E of P and E of Q. Okay, so patch P and Q are from image I. This one is second one is from another image. Okay, so this is how we take information from one to another. Second one is dual bilateral, where we consider edges from the image itself and another image. Okay, so here are the three weights which are there, 1, 2, and 3. So this combined thing is defining as a notion of similarity. Okay, hope you remember the term where we have WQ, IQ. Now IQ is there, and W is the notion of similarity which is based on the these three components. Okay, using this notion, because in medical images uh, we have multiple modalities available. In 2009, authors have defined the using the structure of NLM for multi-component. Okay, where we have C as a component, number of components, typically 3 or 4, and we take weights like this one. Okay, so how patch in one component is similar to patch at the same position with another component. Okay, so let me draw patch P and patch Q in image I1. Okay, and another component at I2 which is of same scene. Now at this P and Q, how they are similar to each other. Okay, so if they are similar in this component also, can we use that notion of similarity over here? Okay, in the image I1. That's the idea. If they are similar in I2, we will going to use them as a similar in I1 also. Okay, so this is the idea of using multi-component or multi-model similarity. So that defines another angle of similarity over there. But issue over here are following. One is images has to be registered. Registered means act the patch P over here in image I1 and patch P in I2 should be representing the same structure or same position. Okay, so otherwise there will be a change of information. These images should have same noise model. Okay, that I1 and I2 are affected with the same noise model. It should not be like I1 is affected by Gaussian, I2 is affected by Poisson. Okay, and also the third question is there should be same quantity. Even if they are having the same noise model, it should be sigma should be same. It should not be like sigma 1 is over here and sigma 2 is over here. That is not that will make like more difficult because then notion of similarity will not be able to capture what we actually looking for. And then how we can transfer information from one component to another. That is another question again in context of defining similarity. We have discussed different notion of similarities, but how we can define similarity from one component to another. Okay, so these are the broader ideas for multi-component denoising, and then there are few approaches that we based on the finding out the understanding the problem of image denoising from mathematical perspective. One is like how many patches we do require actually, or how we can do better patch comparison. That's the notion of similarity. Okay, so we discussed like notion as simple Euclidean distance to define a similarity. Can there be other approaches? So these are the few papers that talks about how many patches do we require, which can be a good similar patch. Okay. Second one is based on image statistics. Can we find out the properties of images? What is the inherent structures for the images? Can we find out and can we preserve? Okay, and then what is the upper bound maximum denoising that we can achieve? Okay, so what is the maximum PSR? Ideal PSR value is infinity. Okay, that there is no noise available now after denoising is there, but it is not happening. So people are keep on coming up to improvise the PSR. Like what is the maximum PSR? Can we find out that this is our upper bound? Beyond that we cannot go. Okay, so there were few papers uh, that talks about finding out the upper bounds over there. Okay, now these are the uh, can be considered like 10-year-old papers. Now things has been changed, so these bounds can be recalculated or recomputed accordingly. A few recent works which were there. One is called based on the self-supervision approaches, where you talk about image itself, which is the notion of non-local similarity. Okay, NLM approach, and over there you take conditions of doing by itself. Okay, how patches are similar, we can have methods over there. So there are few methods called noise to noise, noise to void, void to void, based on the methods which talks about denoising within the images itself. There are methods which are based on the deep learning methods, which are there using all the structures which are there. Like in medical images, UNEC is the well-known architecture which came in 2008 or 9, I guess. So using UNIT, people have done some minor variations with the architecture, and then perform the denoising over there. Remember one thing, in general, deep learning started with the going ahead with the finding out the classifications or segmentations. Okay, so you give labels and all those things. But in case of image denoising, given an image in terms of intensity, what we require as an output is intensity values. Okay, so we have to be careful if you modify any deep learning architecture, you have to get an image back with the intensity values, maybe like ranging of 0 to 255. Okay, so you have to modify your architecture accordingly over there. There are approaches which are unsupervised approaches where we take multiple set of images together to denoise themselves. Okay, and there is no idea that how much noise is there, so we estimate noise component, noise quantity by itself, and that we use for further analysis. The last one is coming up, which is more like an explainable AI-based methods where we need an explanation why these values to be estimated. Okay, so if I say in terms of NLM, so we say that okay, this patch is going to be WI with patch I. Okay, so there are summation of weighted average of patches over there, and how we can configure the weighted average. Okay, can we have some explanation why this is happening? Okay, so XAI is coming up as a new domain where people are working, and there are few papers which can be found out easily on this domain. So this is all about image denoising. So depending on the domain, you have to take a look. Uh, One thing I missed out is there are other medical modalities like ultrasound, where images noise is completely different. Okay, so in like ultrasound imaging, situation is different than what we discussed so far. So these are the applications where different noise models are there, different approaches needs to be devised accordingly. Okay, like one approach may not work for all the methods. So that's the thumb rule. And with this, I think I'm done for the talk. Okay, so I'm open for the questions from the participants.
Thank you so much, sir. So we have a question whether SRGAN algorithm works well for transforming low to high resolution images. It is efficient or not?
Frankly speaking, I have not done work much on GAN as of now, but yeah, GAN approach is also coming up to find out for beginners. So you have to see GAN structures. I'm not have done any work in the GAN for beginners. But yeah, image resolutions, they are approaching, there are approaches to convert low resolution to high resolution images. There are papers available and they are working very well. GAN is the current state of the art method, but for image denoising, I haven't done much.
Oh, thank you, sir. So Dr. Jitendra Kumar had added another line. Sir, I used CNN and RNN to detect the COVID chest X-ray, but want to know more about the testnet to the previous question that we asked.
Dr. Jit, can the participant unmute themselves? Or
So
can
definitely, Dr. Jitendra, are you with us? If you could please raise your hand, then I can unmute you.
I want to know what you want to ask exactly. The question is not much clear to me.
Definitely, sir. Dr. Jitendra, if you can raise your hand.
Okay, let me just answer for others. There are structures available like CNN, RNN, ResNet, the Inception Net. There are so many structures available, but based on the problem, you can select the domain and the structure which is more suitable to the problem. Okay, so it's like not like I can apply any architecture and it will work, you have to do this kind of study, which is more suitable architecture for problem. Like in medical, most of the people work with unique architecture because it's a well-established method and incorporating the requirements from the medical domain. Try to understand in medical, the loss of information is maybe more critical because if there is a loss of tissue information, uh, the the next step, which is like a segmentation, which we are giving to the doctor, may not have a complete information available to them. So if we lost some information in any step, that may cause other further steps in the pipeline. Okay, so depending on the structure which is able to preserve the structure of medical images, accordingly you can plan your architecture, like how many layers to be there, how many parameters needs to be estimated, can we do the transfer learning or not? Because the architectures which are working on natural images, you cannot directly deploy on the medical images. So you need some training data from medical image and then you go ahead.
Thank you so much for answering the question, sir. Sir, I would request you to switch on your camera so that I can take a screenshot.
Yeah, yeah,
And
sure, sure. Let me go out of sharing mode.
definitely, sir. So I request all the participants to switch on their videos if it is possible for them. Okay, thank you so much. So it was really an insightful session and it helped us to know more about medical image deviation. Thank you so much for gracing our session. Uh, and we
Thank
have
you.
another we have another last query for you, sir.
Yeah,
Should I read it?
let me go through. I think I can see. Yeah.
Yes, sir. It says what type of camera is used for capturing MRI based scan.
Uh, it's not a camera, it's a big machine. Uh, if you do a Google search, you can see a machine is of size of a bigger room. It's a more like a structure of a cylinder, a big cylinder, which is having a 360-degree magnetic field, and the patient is lying like this one. If I can show you somehow. So this is a cylindrical structure, and the patient is lying over here. So it gets captured from 3D way. So the machine is quite high, and it's not a camera. It's a magnetic field, which is magnetic field generated over there, and that penetrates the human body. Okay, so its principle is based on the water molecules present in the human body. So idea of MRI is, and those who proposed the notion of MRI, they got Nobel Prize. I think two collaborators got Nobel Prize in 71 or 2 somewhere. So what the notion is, they capture or they initiate the movement of the water molecule because human body has 70% water present in that, and X-ray is causing the effect. So they energize the water molecule particles, and then once they energize, they start releasing the signal. Okay, so that water molecules when they release, so we capture T1, T2, and different molecular structures, and because of that we got the idea of soft tissues. If you have seen x-rays, it gives you more like a bone structures, but when you look at the MRIs, it gives you soft tissues, not a bone structures. Okay, so that's the idea of MRI. And because we have a magnetic resonance, so it's like a signals, like waveforms, and then we apply inverse Fourier transform to get a image like a structure. Okay, because we can't analyze wavelengths or waves that easily. So looking at the images will give us the uh, knowledge about the human anatomy. So there is no camera as such. It's a magnetic field which is generated over there, And if you visit any scanning lab, they don't allow you to carry uh, maybe like if you are wearing some bag or some metal items which are affected by magnetic field. It's a very high magnetic field, like 1.53 Tesla kind of thing, and it also creates a lot of sound. So you will see it's a closed chamber. It's creating a very high noise also, and patient has to be there for 20-25 minutes. So it's a very high magnetic field which is there. It's not a camera-based approach.
Right, sir. So thank you for answering the question. We have a small question.
Yeah.
MRI and CT scan difference by Vijay Tripathi.
Okay, so MRI is based on magnetic field. CT is based on tomography. It's more like on sibling of X-ray. So because X-ray, we penetrate high X-ray beams directly to human bodies, and it only gives 2D structures. Okay, but our anatomy is 3D. Okay, so we need a 3D structure. So CT is more like a sibling of X-ray, which gives a 3D structure. Uh, that's a major difference, and the amount of beam that we throw on the patient body is quite less. So that's the major difference between X-ray and CT.
Thank you so much for answering all the questions, sir. I think the audience has asked the questions. Thank you so much again.
Yeah. Thank you, everyone. Thank you, and we'll see you tomorrow again for another session.
Definitely, sir. Looking forward to it.
Yeah. Thank you.
I request all the participants to please join back again by 12:15 p.m. The next session will start from 12:15 p.m. You can stay here as well. And thank you so much.
Good afternoon, everyone. I, Archita Arora, on behalf of Indira Gandhi Delhi Technical University for Women, feel privileged to extend my warm welcome to all present here. Today's talk on introduction to Python for data science will be presented by Mr. Jignesh Patel. Mr. Jignesh is currently working as an assistant professor at Charotar University of Science and Technology, Gujarat. He is pursuing his PhD degree in Information and Communication Technology at DAIICT Gandhinagar. He has completed his ME and BE in Electronics and Communication from Gujarat Technological University and North Gujarat University, respectively. His research interests include machine learning, deep learning, remote sensing, image processing, and computer vision. He has published and presented multiple research papers in esteemed international journals and conferences. Over to you, Jignesh, sir.
Thank you. Thank you for my kind introduction. So, good afternoon, one and all. I am going to present my speaker right now. So, please. confirm it. Are you able to see my screen?
Yes, sir, we are able.
Okay, so thank you once again. So for the today's session, introduction to Python. Basically, I compile and I choose some of the required library from for the data science, and I will start from the basics of the Python to the deep learning library, and I choose some of the basic functions which you may use for the your data science work or any research work. So to utilize the time, I already run this Python notebook, so we can directly discuss the result. So in between, if you have any doubt or anything, then you can ask me by interrupting me, or you can chat it in the put your query in the chat. So, so what's a Python? So Python is basically object-oriented programming language, and it's a high-level language, and is totally provide the huge amount of libraries, and nowadays is very famous for the data science and other things. Reason is it's easy to learn. It's made intuitive, so you can use the intent and all. You not need the curly braces and all. So it's easy to learn, and directly you can start working on that. So for the any programming language, we first need to understand what are the data types in the programming language, and then we can see the how the loop and functions and all are working. Once you have some basic knowledge of the library, then you can use some of the libraries which is based on that for your advanced task of data science. So let's say we start with the Python. So in the Python, you can directly write the numbers, and you can directly use the operators like the plus, minus, multiplication directly. So first of all, this is a Python notebook which may be shared with you participants. You can run this Python notebook directly in the Google Colab or Jupyter notebook in your system, and whatever need to require to install, it's already written in this Python notebook, so you can directly run the cell and you can have that inside your Python notebook. So why I choose the Python notebook? Because Python notebook is an interactive, cell by cell you can see the output. So when you are doing some work, so you can use directly the Python file, and you can call different Python file. But when you are understanding something, then its interactive environment ID is very better in compared to the normal Python files. So see, normal operators are there, and it's a pretty much uh, uh, so so it's a pretty much automatically is an intuitive library, so automatically take the value. Let's say here in the case of x directly equal to 1, so I didn't provide any dot, so Python automatically consider this as an integer. But if I provide the dot and write 0 or something, it's automatically considered as a float. So defining the data type is very easy in compared to the others library in Python. And it's also based on the operation, also define the data types like the a is equal to 1, b is equal to 1. If I divide c is divided by c, a is equal to divide b, so automatically division operation mostly result in a float value, so it's by automatically set the value in a float. In case of the multiplication, it's an integer. You can try out different mathematical operator using the numbers in the Python. So also support the boolean variable is written like the T capital and other in a small true and false. So it's like the boolean logic is mostly used for the conditional or some decision making instructions. So here I take the cases of the greater than. So if I take the a is equal to 10, b is equal to 5, c is equal to 7, and if you apply any comparative operator between this, if the condition is true, it will comes out as a true, or otherwise it comes out as false. So a greater than b is a true, and if they greater be true or the b greater than c, there is a true. You can also have the conditional operator like or and is mostly used simple English keywords to make it easy to understand this language. So you can use or and or directly like this. It's also support the string, and string basically written in the Python by the inverted comma. You can directly write in inverted comma, and the compiler consider this as a string. You can assign it to variable. You can print it. You can assign to the variable, and or some of the functions, the strings, lots of functions are there. I am not introducing all, but you can as per your requirement, you can directly search on the each library documentation that different type of function. So here upper, so function basically directly written by the variable following with the function. So automatically that function is called this name as argument, like it's like the same way in a C++. So you can directly name is go inside the upper and it will give the output that all the small case is upper. Split function basically divide based on the space. If you use any different delimiter or the like comma or something, so it use and depends on that it's split. So here for the case, I use the key to split the string. So this string is containing the hello word, but is keep the e and it's split the string in a two part. So these are the some basic about the string. So the lots of functions are there. You can use the dot format function to have a very good print function. So like the my name is and in the blank in the curly braces and I am in curly braces years old. So automatically dot format as per first come first will display. So first variable display in the first curly braces, second bracket, second variable is different to second. It's very simple. So these are about the Boolean string and now list. So list is a very general kind of data types inside the Python. So list can have numbers, list can have letters, list can have a string itself. So in the list, okay, like I try to zoom it. This is okay now?
Yes, sir.
So,
Okay. So list have some mixed number of mixed. Even list can contain the other list also. So it's a very generalized data type. So here you can see list of numbers is there, list of string or the character is there, and we can have a list of mix. So you can directly have a for the list of number, list of string like that. It's as I say, this is an intuitive language. So whatever comes in mind, if you try in the Python, you may find something which is relevant to our intuition. Let's say I want to print, I want to check that particular element is present in the list or not. Simply write A in the list number, so it's give the false. But if I write the A in list string, it's give the true. So it's a very intuitive. You just need to use the simple functionalities. You can print with if you have Python 3, then you need to use this round basis. Otherwise, in the Python 2 or something, it's directly print using a double inverted comma. But nowadays Python 3 is used, so use the round bracket. You can access each element by the indexing. So one indexing again start with the 0, 0, 1, 2, 3 like that. So if I write the 1 in the list of the mix, you can see this is a D second character. It's will display. It's also support the reverse indexing. Reverse indexing means the last element is considered as a -1, then -2, then -3 like that. You can have a reverse indexing using the minus sign ahead of your index. So here -1 is used. So in the you can see here is a list of string as an element in the list of mix. So that is going to print. You can append whatever element you want when like you want to create the variable size variable or to store your data, or you want to continuously update your variable as your output comes. So you can always update using the append. So append will add at the end the words whatever data type you want to, you can append in the list by append. Lots of functionalities are there. I cannot cover all of the things, but you can search on that search that on the internet. Basically, you need to remember that for the case of a list can support number, string, or the list itself in inside this. We can say it's like the array, but array with multiple data types. You can have any function with the list by dot and follow with the function name, and depending on argument is required or not argument, you can always have that function. Now these are another dictionaries. So nowadays when we consider the data structure is the most important part inside the our any programming, because we have a very long code with your own logic. But if you use the hashing and table type of structure, so you whatever data you have, you use the hash table we can consider. So mostly in any language, hash means you all link your data with some keys, and then you use some type of some type of mechanism, so it's easy to access and easy to process. So it's very easy to use the this type of data type. So dictionary is supporting that. So if you want to use the concepts of like the hash and table in your programming, then you can always use, and you can always define data structures in the data in the dictionaries. So in the dictionary there are basically it's start and end with the curly braces, and it's have the key and the value. Key and the value. Again, it is not limited to single data type. You can have a multiple type of multiple data types inside the same dictionary. You can have a number, you can have a name. Let's say you want to create the database of the student using the dictionary. So student name, student age, student ID, you can have that as a key, and whatever value it may be float, it may be integer, or it may be string, you can have inside the dictionary. Dictionary mostly accessed by the key. So whatever key, if you it's in this dictionary me, the name is a key. So if you access with the name, then it will show the relevant value from that. You may not aware about the dictionary's keys, so you can list via the keys. Whatever type of values in their dictionary, you can directly take by the values. And items, so this basically it comes as a pair of the tuples. So tuples is here, but I will explain it again. It's a tuple. So tuple is both basically it's again different data type, but in the dictionary whatever items are there, so here only two items are given, name and age. So they both are as per the pair, it will given as a tuple, and you can use that items. So this mostly used for the just representing the data and the accessing. Again, I said as if I can assign directly uh, dictionary name is equal to JRP or something. So automatically, if you represent uh, this will change the A, this dictionary means. So in name key, it change the value JRP. And what's the beauty of the Python? But it's you need to take care of also this. So what's the beauty of Python? If you change any value in the relatable variable, it will change in all the considered variable. Sorry, all the predicious variable. So here A is created from the dictionary me, and I change the dictionary me, and if I print A, then also you can see that variable values is changed. So basically, sometimes you run the program and you forgot to do this thing, because we have a simple practice that we can directly assign to the new variable, and we do some coding, we do some updating the value and all. So it will update the main value. So sometimes dot copy type functions are there, and we want similar type of variable, then we use a dot copy rather than directly applying. If I want to change some value in a some b, so I will take the b is equal to a dot copy. So b have a copy, b have identical value. But when b changing b's value change, it will not affect the value of the a. So it's an advantage, but you need to take care. So tuple basically is a fix. You can simply in the rounded is again data type, simple data type. You can simply have a tuple value, but you cannot have a uh, assign the value. So let's say you define some predefined values that let's say you consider, let's say you want to use something to do the signal processing. In a signal processing, you consider that you fix the Fourier transform coefficient for FFT or something. Just I'm giving you an example. So if you want some fixed numbers of values as a set, you can always use the tuple. It will be not 10. If I run this, it will not 10 the value. Another is a set. So in a set, you can define in the curly you can define. So set and dictionary maybe mix up, but in the dictionary key column value, but in the set, we simply directly enter the values, and it will, so set have a, you can add the elements multiple times, but set can be, when you print the set, it will show only unique times, only numbers, only enough for the one. So these are some basic of the data types. Lot of methods are there to access this data and all. So you can take a look on that. Now how the equals statement is implemented in the Python. So basically in the C language or any other language, we use the curly braces type of structure. But let's say consider that Python is made by some lazy person. So he or she uh, don't want to use that curly braces file. So they consider intent as a next part. So you can see here if a greater than b, then I provided one tab or one space, so it's automatically indented. So meaning of this is if a greater than c is below the if a greater than b. So first if a greater than b is checked, then and then if a greater than c is checked. Likewise, then else if is checked, then else if is represented by the elif and else and at the last. So basically you need to check with the intent. So if you forgot to intent, you may get the unresponsive output or the error. So you need to check. So by default, it's maintain the coding standard. In the coding standard, you always say to the coder that follow the coding standard, so it's easy to follow. But by if you do the programming in Python, some basic coding standard is there that you need to provide the intent always. You can also have a for loop structure. So again, it's very intuitive for I in a range. So range can have a high values and it can print. So you can use the print function. Again, I provided intent. So it take the 0, 1, 2, 3, 4 and print. So you can take the array type of structure and also you can take the values from that. So difference is that. So there you define the array and I take the value. Here you define A first and I is take the value from this. You can also have the enumerate type of this. So if you have a list with the characters, strings, and you want to provide some indexing with that, and you want to create a tuples pair with its index, that this one is 0, 1, 2, 3. You can directly use the enumerate, and it can directly take the two values as a single tuple. So likewise, you can use here join and some function if you want to take the two values in a single for loop. So you can take like this. You can have let's say if I want to print only first character of this, so you can have an indexing. So I is equal to 1. So this row is a column is representing 0. This is representing 1. From the 1, first element is a 0. So I printed like this. And this is also very good feature. You can use a for loop in inline. So inline functionality is given in the Python. So as I already said, it's a very intuitive language. So if something comes in your mind, you simply write and it may have a functionality available in the Python. Let's say you want to create some list. In that list, if you want to use the for loop, that I want to use the for loop, I want to perform some function of like the squaring of the number. So I simply take the numbers from this range and I do the squaring of this. So you can directly write inside the list. This is defining the list. Inside the list, I square. So this double asteroid means the power. It's a power operator. I square and I is taken from the range 5. So first 0, then 1, then 2, then 3, and then 4. So it directly happen. Let's say you want to do the modulation. So I modulo 2. So it will give the 0, 1, 0, 1, 0 values from the modulo operation. So it's nothing but the reminder. While loop, in the while loop, in the for loop, you have a predefined numbers of instant as per your condition. If you want any condition, you can use here break, continue, all type of data types available. So all type of functions are available in this also. So in the while, you need to provide condition first. Okay, and whenever you use the statements, some defined statements, then you must have to write with the no bases are required, only column is required. So if condition column, if condition column, for when the statement complete column, and then it defines the starting of the statement. While loop condition, and then it define the starting of the statement. So is again use the square and all. Function used by the defining the def function is define the function. So you can use the def print. You can provide default value inside the argument section. So whatever you provide, it considers a default. If you want to, so it automatically support the that overloading type or in objective or oriented programming. We have a operator overloading and like overloading of the functions are there. So if you have a single argument, then also yes, Gagan sir, I will share this code. I already shared. Maybe you will receive after the session. So so in that, if you not provide the argument, then the function also run. If you provide one argument, then the function is run. Two argument, then you provide the then also run. So in the constructor part of that, we write that different type of the constructor to hold the data. But in the Python, it's like you can use the argument itself to provide the default arguments. And if you provide the argument while calling the function, it will take that value. Otherwise, so if here I didn't provide any value, so it take the hello because it's a default value. But if I provide the hello world, it take the hello. You can have a different functions like that. This is a squaring function. You can use the some print and that. Now this is again in inline function like in this to create the list we use the I square one instruction. Instead of that instruction, you can also have whole Python instruction considering the function also. So I can use the square I, where I comes from the for I in the A is automatically squaring value. So basically this list is created by the calling this function and taking the argument from this. So it's a very intuitive. You can take any function here and you can provide the data using the for loop. Lambda is a likewise for loop you can have in the inline. If you want to use the inline function, then you always use the lambda. So lambda is nothing but define the inline function. So here I define this object and I given the object name square 2, but this is a lambda function up to till this is called the lambda function, inline function. You can use inside the list or something. So lambda a to a square. So only single line is there. A variable square. So when I use the square to similar effect you can have here for I and I want to a. Okay. Now there are various functions available to use this along with the lambda. So lambda is used pretty much in the data structure type of coding and all that. When we are creating some data types and we directly want to create the list using some type of conditions or some type of some output of the functions, then you always gonna use the map and filter type of functions. So in the map, basically it map the function with the variables, as name suggests. It's intuitive map. So it map this function with this variable, and it's map as per the occurrence of the variable. So here in the lambda function, a and b is occur. So a is mapped with the first variable, b is mapped with the second variable. And now you can have a x and y as an array itself. You can have a x and y as an array. So you can see here y and x array both are defined. Array means the list. List is provided, and these values are taken from the a take the plus 0, then y take the 1, and 0 plus 1 1, 2 plus 3 5, 4 plus 5 9, 6 plus 7 13, and 8 plus 9 17, and list is created. I wrote a list. So this object is converted its output in a list. But so map, you can define any function here. Here I mentioned lambda, but you can have this function also. But that thing is, you need to provide the variables. First variable linked with the first first argument of the lambda function, or the first argument of the lambda function is linked with the first variable, second with the second, three more, any more. So it's follow the ordering and all. Filter is a different type of function. It can use for the filtering. So here you can see lambda x modulo 2. So if equal to 0, so is automatically consider only even number. And this condition is true. This function gives the true and it consider that value. So input is z, which is given take as an input in x. Its modulo by 2 is equal to 0. So automatically give the even numbers of value from this list. So filter is used to filter, but is required the first function and then also associate variable. Map is also required the function and associate variable. So this is the bit. There are a lot of other functions like map and filter are available in the Python library. So this is about the basic Python. If you install the Python, it will give this basic functionality, and you can have some string manipulation, array indexing, and type of the logics and all. But in the machine learning or in the data science, we always do operations on the number. If we have an image, we consider as a number. If we have we consider the number of matrix. If we have a video, we consider the 3D matrix. If we have a speech signal, we consider 1D numbers. So ultimately, our computer operates on the numbers. So we convert whatever we have as a signal inside as a numbers. So mostly we are operating in a numbers. So NumPy is the library which is used to operate with the number. So NumPy, you can consider, if you all are aware with the MATLAB. So whatever function you have in the MATLAB, you can find in the NumPy library. So NumPy is again library based on the Python. You can use inline command like this to install your library directly from the Python notebook. You don't need to go in the terminal and you need to write. When you want to access the terminal from the Python notebook, you simply write the exclamation mark and then this is the command line. When you write this, it directly goes in the terminal and run it. I already run, so it's so the requirement satisfied. If you have not run, is going to install the NumPy library. Okay, you just need the active internet connection. And if you're using the Google Code Lab, NumPy and some libraries are already installed. But if some of the libraries not installed, you can use directly this command line function to install that. So this is about the Python. Now, if you want to import any library in your current program, So you can have this keyword import keyword. So import keyword and then follow with the library name. So then library. If you want to use this name, library name in your function, it may be long name, or you want to represent that with some small 2 or 3 letters, you can use this as keyword in the NP. So as name suggests, as you can read, it's simple. Is it's follow its meaning. Import numpy as an NP. It's mean from now onwards from this cell, when I write the NP, is represent the numpy which I imported from the Python library, which I imported in Python library, which I import. So I import the numpy as an NP. So whenever I use the NP, it all the functions from the numpy library. So in the NumPy, you can easily have a numbers array using an np.array. You can have a 2D array using like this. So you can see here the single if the single row is presented, so it will show only single 1D array. For the 2D, you use the 2 bracket. Inside the bracket, you need this is your row 1, this is your row 2. Likewise, this is your row 3. The comma separate the rows, and if you want a 3D, then also it's a possible. So it's basically follow somewhat like the MATLAB only. You can have access using the indexing like the first row, second element. So numbers are starting from the 0. So second row, third element. So second row, third element is 23. You can see here. So you can access any variable using this way. So in the list, it's not possible. In the list, you need to mention in a. So this is a little bit difference. So here you can see in list we need to write like the B1 square bracket complete 2 in the square bracket. So it's like the B1. If you have a list and if you want to access the first second element 2D element, then you can need to write like this. Okay. So this is about the list, but in array it's easy. So you simply need to write like this. Arrange is a function like the range. You have a start point, end point, and what is the difference at what interval you want. You can have using arrange. So one interval, 1, 2, 3, up to 9. Line space, link space, we can have a provide the link space exactly separated by the provided numbers of. So you, if you want 1 to 9, between 1 to 9, you want 9 values. So automatically with the equal space, by considering the first and last element, it will show the values. If you, let's say you want to have a 10 values, or then you can also simply use this and it will consider the first and last element, and as a equal distance, it will show the included values. Some important arrays by default is like zeros. Zeros you can define 5 1D array, zeros 2D array. Likewise, ones is there. Then we have a I, which is identity matrix. So this is about the basic NumPy arrays. Now it's okay. So you can access the numbers. You can define 0 arrays. You can define 1 arrays. But when we do the data analysis, we always include the randomness. So we consider noise in our data and all, and we want always want some random. So for the implementation, we always consider some random noise is available in the data. So then and then we can perform. So noise, how to import noise is an important task in the on machine learning task, machine learning or the data science. So basically, you have a NumPy, have a random library, and from the random you can have a different type of the random available. I shown here 2, 3, but you can have multiple. So rand is a normal uniform random variable. Uniform random variable is like the is value 1 between provided period. It's provide value between 1 between value between 0 and 1 uniformly. If I generate the 1,000 samples of the random variable, then the probability of occurrence of each value between 0 to 1 is equal. So in a and there, so you can also have a 2D random variable. You can have a multiple normal distribution. So normal distribution is we all use that all the data because of the central limit theorem in statistics. If you generalize the noise or if you generalize the whole data, it will always form the normal distribution. So that's why normal distribution is very important. Sometimes you want to generate the random integer, you can use the random integer. So these are the some type of the random functions. You can have single value, multiple values, matrix, anywhere. So integer 1 to 5, and you provide the dimension of that 1 to 5, so it will generate the value between 1 to 5. Now some methods are there. Likewise, in a dictionary, in the Python, you have some methods here. So you can directly have by dot follow with the function is automatically give the values. So I generate the 1,000 values using the normal random distribution and 1,000 values using the random normal distribution. And what is the minimum of that? You can directly find using the minimum. What's the maximum? You can write the maximum, mean. Lots of functions are there. Mean, max, standard deviation. You can directly use that functions. A lot of functions are there. Argmin, which is providing the minimum value argument. So you can see here the C, four values are generated randomly, and you use the argmin, so it shows 0, 2. So 0, 1, 2, it will show that this is the smallest value. So it will give the index. Sometimes we need the index of the minimum value. Then argmax, likewise you can do. You can always check the shape, why the follow with the shape, and you can reshape the whatever shape you have. Let's say C is the 4 cross 1, so 1 cross 4. If you want to convert in a 2 cross 2 array, then you can use a rightly reshape function. So as I already said that you can consider any data inside as a number. Let's say you consider the image as a number and you want to pass that image as a single 1D array. So you can always have this type of function to flatten that or to set the as per your algorithm. So you can always set. So the flatten is a simple function that convert any dimensional library in a 1D library. Is automatically define the type. Same I already explained. So is as you write element, depending on the element, it define the type of the array, numpy array. If you write the integer without dot, then it will consider the integer, otherwise consider float. Now, indexing and broadcasting, which is the two important parts. So first we consider the 1D dimension. In the 1D dimension, we consider this array. If you write simple column like the MATLAB, it considers all the element. You can access element by the number. You can also have access the element with the providing some range. And again, it's negative indexing is also provided. It's from the start, end to start. Like you can have a start and you keep the blank, then it will consider the start point, and from that start point it shows the all elements. So this is a 0, 1, 2, 3, 4. If I start with the 2, so it will show 2, 3, 4. You can have a blank at ahead, then it will show the this. So these are some basic indexing type. You can directly assign the values. This is called the broadcasting. You can directly assign the values to the multiple elements in the array. So I shown here is a column 2 is equal to 10, then is automatically assign value 10 to 0 to 0 and 1. You can also assign the value in the range also 2 to 5. You can directly assign and you can have it. So yeah, I already explained this. So A is defined here 0 to 1. I use the B is equal to 8, 2 to 7. So B is now have a chunk of 2 to 7 from the A. 2, 3, 4, 5, and I assign the value of the B between 2 to 5, 10. So it will replace with the 10. But when I print A, then values of A is also changed. So that thing you need to take care when you are doing the programming in the Python, because Python track record the links between the variables. So A is directly linked with the B. So when you change the value of the B's, whatever respective value is changed in the A. So if you don't want that functionalities, then you simply have a copy of that variable, and then you do the change, then it will not change the particular. So it's again 0, but it not change the particular values inside the source array. So this is the basic kind of indexing we have in a numpy array. 1D. If you have a 2D, then similar way you can have a separated by the comma. First is show the x and second is show the y. You can also have the range access 1 to 4, 1 to 4. I directly assign the 10. So this is a 5 cross 5 block of the random numbers, and I can directly change this match values of the 10 directly. So this is the way you can have an indexing and broadcasting in the numpy array. You simply can write any range and any value. In case of the 2D, the two values are separated by the comma. So basic. Also, NumPy directly support the logical operator to the filter the outputs or something. Let's say you have a random array. Let's say A, you have a random array of the n 5 cross 5. Normally, random value or normal distribution value varying from the -3 to let's say +3 most of the time. Let's say you want to check that how many values or what are the values which are greater than 0. If you simply write that A greater than 0 is automatically apply using the broadcasting is automatically applied this condition throughout the elements, all elements, and it will result based on the value itself. So if value is greater than 0, it will give the true. If value is less than 0, it will give the false. Also, you can use this as an index. So likewise, here we use some rank 1, 2 or 1, 2 is equal to 10. You can always use the logical output of the logical indexing inside as an indexing. So you can see here true, 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 false is given. So if you use this a greater than 0 inside this, so this a greater than 0 now become the indexing. So whenever the values of the a is greater than 0, it replaced by the true. So here is a true. And we apply whatever the position true is equal to 10. So automatically true replaced with the 10. Means whenever true, it replaces with the 10 and others are same as a previous case. So here the whatever values are greater than less than 0, minus 0.25, minus 1.03, it will remain the same. But because of this condition, we can use this this is mostly used in a clinical data, and when we want to change some value, some outlier, you can always control using this type of logical operators for the indexing. So for particular index element is an outlier, you can simply replace with the mean value. Normally we follow that to remove the outlier. We are going to discuss in some time. Okay, so this is about the logical operator, and you have a similar operator like the plus, minus, and all. But yes, again, the array broadcasting, so you can directly apply the operators to the both the to the array. So a plus b, so automatically perform element wise addition, and it will show the result here. It will follow. You can do this b minus 1. So you can see here is a 1, 3, 5, 7, 9. So all values comes as a. So if I check d is equal to a, it will again give similar kind of thing. So what is the output of this? It will be the true, 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 true. All the elements are true because of if you subtract this from the this to the 1, then it will give the c is equal to true, true, true. So if I check the any value of the c is a true, if you check the all value of the c is a true, then is also. So if you want to check the what is the value, any value, if you use the any, if any of the value is a true, it will give the true. Okay, any of the value. Let's say you consider d is equal to 3 array, this array 0, 5, 6, 9, 9. And if you confirm the d is equal to a, so it will have a 0 only at this position and others are different. So it have only true at the position first here, but all other are conditions are false. So let's say what is the array of this? It will give like a true, false, 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 false. So when you do the any, it's give the true, but when you do the all elements are true or not, then it will give the false. So these are very important when we are crunching the data and when we are checking the data types, what are in the data, and what's when we are performing the cleaning of the data and all. These are very important function in any and all. So this about the operators. We have a lots of function in the NumPy library. You can, I already provided link, but you can have a from the internet. So again, arrange, it will arrange. I choose directly square. If you want, you can directly square the num value. If you want to use the sign function, it will perform the sign operation on the argument, which can be array. Exponential operation, then it can be this. So basically, you whatever you want to do with the numbers, you can do with the number. NumPy is totally provide support for the numbers. If you have numbers in any form, then you can perform any algebraic operation or the linear algebra operation or the calculus operation using the NumPy library. There are various libraries. Let's say your work is include the linear algebra, which is by default in the machine learning. The linear algebra is there. So NumPy also have the linear algebra library. You can directly check that library. So in there directly standard deviation and different type of function mean and all you can have from that library. SciPy is another library for the calculus type of functions. So you can explore that and with respect to the mathematics. NumPy also. So now we start the Panda library. So in the Panda library, so pandas basically you can consider as a index Excel of the Python. So basically, in the initial days of the data science, we always use Excel because Excel is a very important tool. Very easy to access tool. You can directly have a data in terms of Excel, and you can perform the operation based on the columns, arrays. You can also write the meta. functions or some macro function to perform in some Visual Basic script or something. So if you explore the Excel for the data science, then you must have come that you can use the macros functions to perform some operation. But the pandas is a very good library for the data science, and it will provide all the type of functions to perform the data cleaning, data accessing, performing the operations, the data, mathematical operation on the data. So basically, you can pandas give the open the gate how to handle the data. So you can handle the data if you have in a CSV file or in a HTML file. Also, you can read from the panda and you can access it. So again, you can install like this pip install pandas. So for the pandas, you can use again I use the import pandas as PD. Now similar is a array and array. We have a panda with the series. So basically, panda is take the record of the data type also. When you use any panda series, it will show the data type, relevant data type. So integer 623, it will have the data type. So like you have keys in the dictionary, you can have that type of functionality with the panda also. So in the series, you can define that 623 is a simple data. So if you don't provide any indexing, then it will consider by default indexing of the numerics like the 0, 1, 2, 3. So whatever data you have, simply index with the 0, 1, 2. So basically, in the Excel, we always have the A2. So it's automatically say that A column and second row. So indexing is much important part in the data science. If you have a very good indexing, then you can easily operate the data and perform the different operations. So Panda series directly give the basic indexing. Sometimes you want to give the name to that index. So you can give the index name like A, B, C, D, F, and GHI are given. So it's automatically linked that first variable as ABC, second is a DF, it's like the GHI, like this. So, and again, like the key, you can have access the data, you can access the data using the, so here I write the same thing, A is equal to, so using the key, you can have a data, like the key in the dictionary, you can have an index, and using index, you can directly access data. What is the value of ABC? If I write like this, it will give the answer. So by default, this is the functionality in the like this you need to initialize. But by default in the Python libraries follows one rule. It you can have in any order if you provide the name of the arguments and equal to sign. Let's say the name of argument is index. It's the name of the argument, and what value you are providing is given by the equal. But it's also follow the ordering. So if you don't provide any name of the argument, so it will consider the default order. So default order of the series is first element is considered as a data, and second element is considered as the index automatically. So if you don't provide the like this and you use likewise, then also it gives the similar out. Okay, and yes, here you can directly provide the list or the numpy array. And I mentioned that this is a similar kind of structure like the dictionary. If you have a dictionary, ABC is equal to 6, DF is equal to 2, or GH is equal to 3, whatever, you can directly use dictionary in the series. So you don't need, it's a overloading is here. Overloading operation means you can have a multiple type of argument using the similar kind of function. So series, if you consider the function from the panda, so it can take any argument, it can take the argument in the in sense of the list, and along with the list, it's index or it's a numpy array and in index. Also, you can provide the directly dictionary. So dictionary already have a key, so it directly link the key with the index, and you directly have this. Beauty of the panda is that you can also have function itself as a part of the series. So this list also support all the types. So you may have a list with the function, and you can create the let's say here I created a array, and B is the functions series of the function. So in that the sum, minimum, and max functions are given. So if I write the B is equal to 0, it means its first element of the series is the sum. So it performs the summation of the array automatically. If I use the B is equal to 1, then it takes the minimum as a function. So minimum and take argument as a A, so it will find the minimum. This is the maximum. So b is equal to it's a maximum, it will show the maximum value of this. Likewise, you can have any numbers of Python function as a list, and you can have that as a series of the pandas. Again, we take the two dictionary, and the beauty of the dictionary also in the dictionary. So if let's say if you want to perform the summation operation, so in a list, in array, it's very simple. It's do the summation by elements wise. But whatever data you have, let's say you have a data of the student database, and let's student database contain the marks of the internal examination and then external examination, some bio marks. So 2-3 types of values are there. All these values are linked with the particular index term, student 1, student 2, student 3, like, and you want to add at the end semester, after the end semester you want to add that, so you need to add as per the indexing. So that functionality is provided by the panda itself. So depending on the key, it will add the data based on the key. So a is data add with a, b is data add with the b, c is data add with c. So any operator you can use here, simple operator you can use here, and it will add based on the key. So a plus a, whatever value of the a, it added with this, added a, b to b, c to c, like that. If in case you use the different, let's say I provided d here with the 20, and I do this, so it will see the d is equal to nan. Why? Because not a number. Not a number is when we don't have a value or the blank. Let's say if you have Excel and then some cell are blank in the value, some garbage data is there, then it replaced by the nan using the panda library, directly is replaced by the nan. So here you can say d is equal to 20 is available in a, but a plus b cannot perform the d from here, but d is not available here, so it will be the nan. So very generalized uh, functions you can apply, any function you can apply using the panda series. You can also have the lots of functions of the series from the panda library. This is about the series, which is similar kind of the array or the dictionary you can consider. Then comes the data frame. So most of the data we don't have in only single array, because single array means you can consider one data sample as a single array. One data sample as a single array means it's a one array representing all the features. So in the most of the time, the data science, we have in the rows as a sample and the column as a feature. Feature 1, feature 2, feature 3, feature 4, like that. And for the sample 1, we have value at 1, 1. Sample 1, feature 2 value at is a 1, 2. Likewise, you have a whole data frame. So in Excel, you have a data like that. So column representing the features and the rows representing different data samples. So data frame is a very good placeholder to take that type of data. Basically, we can say you can save the 2D data using a data frame. So here again you can have a numpy array or a 2D as a data stream, and if you don't provide any indexing, it will take the default indexing like 0, 1, 2 and 0, 1, 2. If you want to provide the indexing in the name of the columns, let's say x1, y1, y2, y3, or feature 1, feature 2, feature 3, you can have column names. So it must be matched with the numbers of columns in your data frame, and it will assign the name is the y1, y2, y3, and when you print this, it will show like it. You also have indexing such as a series. Like a series, you also have indexing also. So if you provide the indexing, it will give the name to the rows like x1, x2, x3. Let's say sample 1, sample 2, sample 3 if you want. You can always have using index. You can have both using the index and column, so it looks similar like the data frame. So whatever data you have, mostly in this form. Whenever you use the data, it's mostly in this form. Most of the time columns is most needed because it is define the features. Sample name, it's okay if you don't have, but you can always neglect that sample when you are doing the data process. Sample name, like you are performing some machine learning on the student database, you can ignore the student database and but you can assign the name on the each row. So as I already say, if you provide the name, that's okay. Otherwise, if you not provide the keywords for the assigning argument, is automatically take the default argument as per the order. First is for the data, second is for the column, so index, and the third is for the column. So automatically take based on the order. So this is about the basic of the data frame. Now, how handle the data, indexing in the Panda is very similar to the handling in the NumPy or sorry, not in like a dictionary. you can directly have the column name and it will show the data. So this is your y1, y2, y3, x1, x2, x3. If you write the y1, it will directly show 1 for 7. It's also follow the SQL type of data things. Dot y1 you also can write and it will show the y column particularly, y1 column here. So you can always have. For the row, you need to use the function. You cannot have rows value like this. The localized function, LOC function is used to access the data row wise. So LOC x1 is automatically print the values of the x1. So x1 value is 1, 2, 3. So you can have that value here 1, 2, 3. I location, ILOC is defined the index location. So this is by the key or the index value. Here it's by the key, and here is the index value. So 0 means the 0th index. So x1 is a 0, x2 is 1, x3 is a 2. So if you write the ILOC 0, so it will send, it will again show the result of the row 1. If you want to access the particular data from the some x position and y position of the using the name keys, then you use the LOC. Same way, if you want to use index, then you use the ILOC. You can have a multiple data access also by providing both the x1, x3. So this is for the index and respective y1, y3. So it's represent the columns, and you can have that chunk of the data, that x1, x3, x1, y1, x3, y3, x1, y3, x3, y1, and x3, y3. So we skip the x2 and y2. So it's automatically from this small data pair, it will consider this data. So you can always have the different type of data. You can also have again allocation from here for multiple rows and multiple columns. So again, you can directly add the data. It's very simple. Simply, you can choose the column. Yes, that data size must match in the data frame. So automatically this here. And adding a new column is very easy in the data frame. Sometimes you have a data. Let's say you want to do some kind of function like the linear regression. So in a linear regression, when we consider some elements like the x features, let's consider this y1, y2, y3 as a feature 1, feature 2, feature 3 in your data. And x1, 2, x3 or xn, it's the numbers of samples. So when we do the linear regression, we always try to fit the line like the ax1 plus ay1 plus ax1 plus by2 plus cy3 is equal to 0, and we try to estimate that a, b, and c. But when the data is not a linear, then we need to use the polynomial regression. In that, we use some combination of the features and we create the polynomials. So that time, if by Panda is very easy. If I want to create the y1, y2, y3, and fourth row as a y1 square, fifth row as a y2 square, third, sixth row as a y3 square, then seventh row as a y1 multiplied by y2, then y2 multiplied by y3. If I want to create the complex polynomial, then I can directly have new rows by defining the new rows name, sum, and the whatever operation you want, you can directly, and is automatically added in the data. So it's a very good functionality. Sometimes you find this picture is irrelevant. This picture's variation, we mostly information, if this particular feature is not providing any information or it's not correlated with your labels or something, you can always discard that. So when we perform any cleaning process, in the cleaning process, we consider any data like any features which have a distribution, some like the noise, we simply neglect. So you can neglect any features via like this drop function, drop by the axis 1, so it directly remove the column. Sometimes you don't you have a good data, but some sample you find that sample is a outlier or something. Let's say you have in a data sample x1 to x 100 samples, you have 100 rows of data, and your data is mostly varying in between 0 to 10, and some data point like x6 or something, it have entry like x 100. So you simply consider that as a error outlier, and you can neglect that sample to fit the data, because if you have an outline your data, then your data will not fit data. So you can directly drop that sample. If you want to drop the sample, you use axis 0, automatically the row is deleted. How to identify that particular outlier? You can have some your own logic, and you can have a like the greater than equal to function. Most of the case, what we do for the outlier, if your data follow in that particular column, that feature is varying with some range, let's say 0 to 10 or something. So that feature variation we can capture using the standard deviation. So we can consider, if we consider that any data is follow some normal distribution. So any data outside the 3 sigma, outside the 3 standard deviation, 3 multiplier standard deviation, we can consider the outlier. So we can simply have this type of logical function that if y1, if you are simply considering a single element only, a equal to y1, if greater than the 3 multiply the standard deviation of the a1, I neglect that. So for the for the understanding in this a, we consider a greater than 5, so automatically is give the true value whenever the entry is greater value than the 5. And you can use this as an index, similar as a list in the NumPy, in the dictionary we use, sorry, in the list we can use as an indexing and we can replace that value. So you can have the a greater than 5. So whenever true is get, you get the value 666 something, but others are replaced with the NaN because it's a false. So now you have a not a number. Now you may have a you just want to check that if my y2 is greater than 5 or not. So you can have a that I just consider the my features. Let's, as I given an example, that my y2 is follow some variation between 0 to 1. Here I give an example 258. Let's forget about it. So 0 to 1 is variation, and if the standard deviation it's let's say 1, my y2 column or my y2 feature have standard deviation 1. So whatever greater than the 3 sigma or whatever they're mostly greater than 5, I will consider as an outlier, and I simply want to remove them. So you can directly access like this a greater than 5, and you can have some logic whatever you can define. Mostly is based on standard deviation to identify the outlier. So you directly have, so all the operations, so it's basically a greater than 5 to greater than 5 is give NaN value in this. So you get the NaN value here and here at this location and this location. And when you use this as an indexing, it's automatically neglect that 2 rows which have this. So automatically that samples, outlier samples holes are there, and your data is clean. So this is mostly used for the cleaning process. You can have a multiple logic that my data should not also have the negative value less than minus 3 sigma and greater than 3 sigma. You can have using a simple AND operation. So AND is like this, and OR can be written like using this single call a single bar. You can have all logic. So that way you can have some cleaning. You can always reset the index. Let's say you want to reset the index, then you can use the reset index function. And from the after resetting, you want to make some as an index of this data frame, then you can set the index as a sum. So automatically sum become your index, and all are considered as a data frame. So you can have any index. So these are some basic functionality. There are a lot of functions available in the Panda. So again, the same case here, but what's the problem that when you do a dot set it a sum and you print a, it will again give the same. It will not print this. It will print the previous one because again the same case. It will not change the value. If you want to consider whatever output you do with the a, you want to consider that output, then you need to write one argument is in place is equal to true. So in place equal to true means whatever operation after performing this operation, whatever the change value is a, it will kept in the actual a placeholder. So it will replace by this. So this is something about the data frame. Now multi-index. So this is a rare case when your data have a multiple hierarchy. That's if you consider that first group is divided into two, then each group has two group in the second state, and the second two also have a two group. So let's say I will show the output first, so it will create that. So I want to create data frame like this. So its indexing is like that is a multi-indexing. So it's like the first group have a two subpart 1 and 2, and this each subpart is another two group 1 and 2. You can have a name in this. You can have a characteristic. I just give the name numbers, so it will for the intuitive example. But you can have here x, here as a xx, xy, then xx, x, xxy. Like that, you can use any indexing. You just need to provide. So it's simple layering. So first is divide two part, then second divide two part. But ultimately, we have 8 samples. So you can have a multiple indexing like this. So my first 4 samples are replaced with the first indexing 1, and the last 4 is the second. In the second, first 1 1, then second, then 1 1, then second is defining the groups, and then 1 2 1 2 1 2. So it automatically assigns this 1 2 with this one, this 1 1, and this 1 2 with this 2 2, and this 1 2 with this 1 1, and this 1 2 with this 2 2. And this 1 1 2 2 is assigned with 1 1 1, and this 1 1 2 2 assigned with 2 2. So basically, it's create like this structure. So if you use this multi-index from the Panda, so from this given tuple, if is a function to couple the tuples. So once using tuples, you can have a multiple index. That multi-index you can use in a data frame as an index. So in index, IND is used, which are created by this multiple, this multi-index function, and then you can have the column value. Then you have a, let's say, three variables, three features, f1, f2, f3. So you can have that x1, x2, x3, or f1, f2, x3 here. And here I generate a random data of 8 samples with the three features. So it will show like this. So you can localize this with the again same function, but you keep in mind that is a multi-indexing. So first index like a log 1, so it will give this first index. If we write the a log 2, then it will give this index. Likewise, log 1 from that log 2, then it will take this first, and then this still is represented. If you took the 2, then it will represent this. Likewise, you can easily access the data from this. Okay. You can also provide the name to this indexing, first, second, third, directly by the index names, or you can write that in the function. So this is where you can use the multi-indexing in the data frame. Now I already discussed a little bit about the cleaning of the data, like how to remove the outlier and all. So again, we see in the data frame, let's say I create the random data 5 cross 5. You can have a this. So default argument first is a index, second is a column. So split function is a string function which split the string, as we seen here, split the string in a different elements. So it's automatically segmented x1, x2, x1, x2, x3, x4, and x5, y1, y2, y3, and y5. So you can consider this as a list of x1, x2, x3, x4, x5 element, and y1, y2, y3, y5 element. And so you can have such a frame. And now you check the a greater than -1. So you can have a directly, like we did in this. If you do this as an indexing, so a greater than -1 is give the true false matrix of this data frame. You can use that index, and whenever false are there, it will represent with the NaN values, and others are values are true is considered. So you can directly have a function like the C is equal to drop NA is automatically drop the and if your data set have not a number values. So let's say if you get the data from the some Excel, and your Excel have some garbage data or some data is missing, so it will represent the not a number, and you drop NA, so automatically NaN value is. So NA and not a number error is a very famous error in earlier days of the deep learning, because sometimes 0 divided by something is happened, then it gives the not a number infinite. Sometimes numbers is outside the bound, some graded exploit is happen or something. It always create the very large number than the range. Let's say integer is range, then it's out of the 32-bit range is numbers are created, then it's always generate NaN. So it will stop the training when this come. So handling a NaN, it's a very critical task in the any data science part. So let's say here we deliberately set the two value is equal to 0 0 here in the B 0 and 0, and then we do the data frame operation with A divided by B. So A is simple numbers. This one is A, and we do with the B. So element wise division is performed. So it will create the value infinite here. So this can be the case during your algorithm. In the step of algorithm, you must have faced this type of thing by, like, let's say it's called the divide by 0 error. So it's automatically stop the program, but because algorithm cannot handle the infinite value. So you need some type of functions for the clean the data. Meanwhile, the program you may have you need to clean your placeholders for the data holders, or in the starting of program you need to clean the data. If you have an infinite value, you need to replace it. So you can see here, you can directly use the replace function, and you can replace NP infinite and NP minus infinite with the none value. I do none, it will clear here. So once you have a none, then you have a function like the drop NA, and you can directly drop that. So infinite value replaced via the none. In place is true. So whenever in place is true, you automatically update that value. update that data frame, otherwise not update the data frame. So here you can see you can name and now your data is clean. Now infinite value is not there. So actually basically we drop that sample. So here's a small example of 5 plus 5. So we lost the 2 rows. So it's not effective. But in the data science, we have thousands and millions of data samples, and few of the samples have infinite value. So we can drop that to clean the data. So yes, similarly, sometime if you want if you want to, let's say some features, let's say you have very less data, but you have a very big feature space. Let's say 100 features are there, and you may want to drop the feature. So again, you can convert the infinite value to the NaN using the same function, and you can use the x is equal to 1. So it will delete the column or the feature value which have the none. So it will delete the features which containing the none values. This we rarely use because we have very large data and less numbers of features. If you have very and if features are good correlated features we have, any numbers, it will help in the classification or the regression, any problem of the machine learning. It will help if your numbers of features are large. So we don't follow this practice normally. You can also fill the none value. You can drop, but let's say your data have very bad data you have, and lot of data have a none value. Okay, your data samples have a lot of none value. So the cleaning process, what you can do. So what the base represent the data? It's the mean value of that column. So if I want to represent, I want a mean of that value. So some data you have, and it represent from 0 to 10. So what we can do, if we have an infinite range, we can simply convert into NaN, and we simply convert the NaN value with the mean value. So it follow the distribution. So basically distribution, it may be NaN, it may be different. It may be your normal distribution, which we mostly consider. It's always spread in the both side of the mean. So mean is a very good choice to replace the NaN number. So if your data have a NaN, so you can always replace with the mean. So it will clean your data and it will not disturb the learning process because it follows the distribution. It not create the outlier of your data. So this is all about the cleaning of the data. Now, sometimes you want to so explanatory data analysis. This keyword comes to know. So basically, we have a two things: machine learning and data science. So again, another term is the data analysis. In data analysis, we do data analysis first. You experimented data analysis, some techniques, and after that we are going to use some particular technique to implement the machine learning part. So when we have a very large amount of data, so we cannot have used the whole data without doing any data analysis for the machine learning or the deep learning, because it may give the unresponsive output or something. So for the purpose of data analysis, we always see using different. So mostly we in data science we have a categorical data and number data both. We do in the most of the case, if your categorical data is just confirmed information type, then we mostly apply the analysis. We mostly apply the data science techniques on the numbers values. But we can have a good data analysis based on the categorical values. So here I have one student data I created. So that have three students, let's say STD1, STD2, STD3, and they all appear for the subject exam like the subject 1, 2, 3, and they all graded in the A, B, B format, and they have some marks. So we have a three categorical data, and we want to do some data analysis that how the marks are there. So you can also, this is the, so I want to mention here quickly that this is the way you can read this data from the CSV. If you want to store the data, you can use the two CSV functions. Similar functions are available with Excel itself, Excel read, Panda read Excel, and similar function is also available from the HTML. So some website is providing some XML table already available with the in the website. And if you directly want to fetch that data, then you can have always let's say you want to do some data analysis in the stock market. So you can have some money controller, some type of data site. So in that site, data site, in the most of the time, the tables are put in the as a XML table. So when you use the read underscore XML, read underscore HTML, it's automatically take that page, and from that it extract the table as a data. And you also can write the table in of the CSV format. So we first perform the group by function in the student. So it will show like this. So basically, if you use the describe, so it creates the object. And now you describe this, so it will group in as a student as a category. So student 1, student 2, student 3. What are the different counts? Student 1 have a 3 grades. So all things based on these numbers only. So student 1 have a 3 grades, student 2 have a 3 grades, student 3 have a 3 grade. So it will give the analysis based on the student. So student 1 have a mean grade is a 9, standard deviation is 1, its minimum grade is 8, is a 25 percentile is a 8, 55 percentile is a 9, 75 percentile is a 9.5, maximum grade is a 10. Likewise for the student 2, student 3. Let's say you want to do the analysis based on the subject. So you can have a subject category and you describe, then it will give the subject. Let's say you want to do the data analysis based on the grade, you can have a simple grade and it will give the analysis. So this is mostly used in the data analysis part. So now if you want to concate, these are some basic functions which can become across. You can concate to data frame. If you have a data frame A and B and the dimension is same, you can always concate data frame using the concate function. If the dimension is same, is concatenating in a single data frame. You can also use by the row wise using sys. Similar function is a merge. But merge is follow the key to merge the two data. So here we use the same data A and B student data. And we extract the data for the student 1 and B as a student 2 data, and we want to merge this data based on the subjects. Subject is a common thing in this both the case data frame. So we can have a merge with the on what? On subject we want to merge. So you can see student X, student grade X, marks X, student Y, grade Y, and marks Y, but subject is common and it will show. So you can merge the data like this if you have multiple data. You can join the data based on the index. So if you have a data like the student B is the data is given, and if you want to join this both the data for the two students, how to index do the indexing? It's simple. You can have this like I created this data, small data here. That subject student 1 data, student 2 data, and I want to join this data as a single data frame. I can use a dot join b and automatically join. Okay, some are the imported function. Again, it's used for the data cleaning and all process of the Panda. So you can read the CSV file. Sometimes you unable to read the CSV file, then you can change the engine is equal to Python, so it's able to read. I created some data for the Olympic, current Olympic 2020. It's a country, gold, silver, bronze medal, and is a medal tally. So it read by in the A. When you write the head, it will show some 5 values from this. If you write the unique, it will give the unique values of the so here the rank is again I am accessing the rank column and unique rank is showing that these are the 77 ranks are unique rank we have. Number of unique possibility rank is 30, so rank is here. So it's accessing so unique is give the what the unique values and unique gives the numbers of unique values. Then you also have the base because ranks are provided to multiple countries, same rank. So you can have a count of that using value count. So a lot of functions are there. I am showing some important function. You can directly calculate the mean of the particular column using a directly gold dot mean. You can directly have a mean of the average numbers of gold for the country. So we have an average is about 3.6. Average 3 gold is received. Now let's say you want to fetch the data from the same data samples like the A gold, A silver, or means we consider the case that if the gold is equal to silver or the gold is equal to bronze. So what are the dead data? So you can directly have this as an indexing. So like this is used for the gold is equal to silver data, and this gold is equal to bronze data, and or operation is there. So it will give the indexing. It's give the true false table. And using this true false table, you can directly access the data from the A, and it will give the example that the one of the case is true that gold is equal to bronze or the gold is equal to silver. So you can have that data. Likewise, you can have a maximum numbers of gold you can have. Now, if you want to find out that which country get the maximum number of gold. So you can simply compare the a gold column with a gold max, and it will give the particular data in the United States of America got the most numbers of gold. We want to check that gold numbers are greater than 10, silver greater than 10. Again, similar thing you can observe using this. Likewise, if you would directly access country, it's same. You can have a country and directly you want to access the total of that. So you automatically get the total number of in the total. And we want to check that how many countries are lesser than the India's medal tally, total medal tally. So we have checked the A total less than integer. So it's automatically it is containing the country list. This data samples which have lesser number of the medals less than the India. So it is a 55. You can have the ascending order. False is because we want to have the descending order from highest gold medal to the lowest gold medal. You can have that sorting also functions. So you can also create the pivot table based on the categorical data. So let's consider this again, the student data. You can have a different category like the subject. So you have a value of the marks, index as a student and column as a subject. So you can directly create the pivot table of the data for the easy data analysis, that the rows are referring the student and the columns are represented by the columns, the subject, and it shows the subject pivot table. So this is about the Python data pandas library. It's very useful library in for the data science. To represent the data, we see quickly the two library, matplotlib and Seaborn. So matplotlib library mostly just show the waveforms type of the function, like the only matplotlib type of function. You can have a directly plot function. I am calling this as a PLT, and plot function is plotting the data x, y, x, y. It's shown here the sine wave or something. You can see the cosine wave. And you can have also subplot type function. So plot, subplot, this type of function you can have using this. So 2 1 means the 2 rows 1 column. You have first value, 2 rows 1 column, second value, and it will also you can mention x, y, and what type of pointer you want to use. P is for the mentioning color, R is mentioning the color type of pointer you want to use to represent the data. I created here the data using x linspace numpy data, and simply use the cosine function and sine function as a z and y, and I can show you. Sometimes you want to show the two plot inside the in the single figure. So yes, in the Python you can also access whole figure as a one object, and so as an object or as an advantage of object oriented programming. So you can have a figure as an object, and you can provide axis, and you can have both the data inside the legend in the single column. You can also directly plot the distribution using matplotlib library. Let's say I created data of the 1,000 samples varying between 0 mean 1 variance, data of the 1,000 sample normal using the numpy library, and then I just want to plot histogram, so you can see it all the 0 to 1. Histogram is modeling this basically distribution. You can have a different type of scale like the normal scale or logarithm scale. You can set the scale using a set scale function. So if you are not provide any set scale, then it's considered as a linear. You can provide the logarithm scale using the set by scale. So you can see here the linear function and use a logarithm function. So in the linear, you may not find the detail about the exponential part. So here the two functions are there, x square as well as the exponential. So in a normal case, the exponential and normal it's difficult, but in the logarithm scale you can have a good idea, because in the y scale we have a logarithm, so we can have that more numbers of values in a time y. Again, you can have a 3 data at a time, means x is one column and you have a 2 as a y column. So you can have a twin axis in a matplotlib. This is also very good functionality. Then when you want to represent the two graph in a single plot, so you can have one and second as a second using a twin. So you can see here I use the twin function of the matplotlib plots. So this is about, but matplotlib is give the basic plotting like the matplotlib. It did not give the data analysis or it not give the some insight of the data. So to help the explanatory data analysis, we can use the Seaborn type library. So Seaborn library is providing a very detailed analysis from Panda data frame. So here the one data set is considered the tips data set, which have the tips and total bill, and depending on the tips, its category is a different sex, smoker is not on day, Sunday, Monday, Tuesday, like that time. So this data frame is containing all the information regarding the total bill and tip. So you can directly have a distribution plot for the particular column, that total bill. If I want to plot this, what's the distribution of total plot, I can have this. So you can see it's mostly follow the distribution. It's also give the boundary, so you can see that mostly follow the normal distribution. You can have a joint plot for the when you are comparing, let's say, what's the relation between the total bill with the tip column. So if you draw the joint plot, then it will show the scatter plot that varies from of the total bill along with the tip, and it will also show the distribution indexes. So you can see the distribution is like that, and when the total bill is increased, slide word tip is also increasing. You can directly interpret that from this data. So you can also have a various kind of functionalities are available. You can have this X plot, that scatter plot, various plots are available. You can explore that in the C1. Is the most important. Pair plot is the most important. So basically pair plot is comparing all the features with the values, all the features, categorical features with the values, and it will give the importance in this. So pair plot, let's say the total bill, tip and size. So you can see here total bill, tip and size. These are the numerical values. These are the categorical values. So mostly the pair plot is assigned on the values, uh, numerical values. So you can see the whole distribution. So you can see total bill versus total bill versus the tip, total bill versus the size. Likewise, this matrix is given. So, but total bill versus total bill, so automatically it's represent the histogram, because variation of the total bill, let's say value of the total bill is, let's say, $100, and accordance to here is 100. So numbers of frequency it's automatically representing. So automatically diagonal will show the distribution for the particular category, and the actual most important data is this non-diagonal data. So non-diagonal data will give the information about the relation between the type of the features. So mostly tip is varying with the total bill. You can see here, and you can see this plot here. Total bill and size doesn't matter mostly. It's a total bill is increasing, but it will not give any information. So you can see here it's increasing type. You can find some pattern here, but you cannot have any pattern here. So likewise, you can have analysis, and if your data you have multiple correlated variables, then you can consider the least number of correlated variables, so your complexity of the programming is decreased. Let's say you have a feature 1 to 100, and let's say your feature 100 or feature 10 is highly correlated. It's like a simple line. So you can drop whole feature and then the data, and also you get the similar result. We are going to see this in a machine learning part. So again, you can also have this diagram of the pair plot using for the Olympic data. So you can see here rank is inversely proportional to the total number. So total number is higher than rank is a small number. Means the highest rank is a 1. So it's, you can see when the total number is increasing the rank. So you can directly find the relation between them. For the tip data, you can also, okay, and this additional functionality, this is just two things. But if you provide the hue parameter, so it will also give the third dimension, that tips. Okay, so total bill, tip and size, you already plotted this, but how is depends with the category. So you don't have any only number data, but your tip have a categorical data also, like the sex is there, smoker is there, day is there. What's the relation of this categorical data in this numerical data? If you want to observe, then you can provide one of the category data as a hue, as a pattern, and you can have that analysis. Let's say how male is given the tip and how the female category is given the tip, you can observe from here. So likewise you have analysis. Obviously bar plot is always important. You can have a directly bar plot for the xy category. So day, or each day, what is the tip category? So you can see Sunday is the highest D because everybody is happy, so tip is high when the Sunday is there. So you can have a categorical analysis, categorical versus categorical analysis. You can have with a bar plot. Same way, box plot is very important and very useful in the data science. It will mostly give the all the importance. So basically, you see these dots is represented outlier type of data. Most of the data is spread with the mean and max, and this box is representing the data is most important 25 to 75%. So this bar is representing a 50 percentile, this is representing a 25 percentile, and this is representing 75 percentile. So most of the information for the categorical data you come from this directly bar plot. You can see have some idea, and from this by checking this, okay, this data is too much outlier, so you can from that directly deduce. So what's similar kind of data is a violin plot, but in the violin plot, it's not use the percentile. Instead of that, it shows the what we can say distribution directly in the Y column. So you can see this path in the both the side. Actually, violin is a mirror image only, but it's showing you the distribution, how the data vary. At the Saturday, how the total bill is varying is mostly follow this pattern. If I can see, if you plot the horizontal, you can see that it's somewhat spreaded normal distribution. This is a very spreaded normal distribution. This is somewhat like a normal distribution. So what type of data distribution you get from the violin plot? So violin plot have a different than the bar plot. Is that violin plot also give the information of the distribution. This is again, so from the pair plot, you must have the information of the correlation, and correlation is most important part in the data cleaning process. So that also, if you have very large data, then the pair plot is very difficult with the CPU. If you have a GPU, then it's a very good, very easy. But let's say if your machine doesn't capability, and if you want to find the correlate data, then you can simply find the correlation of the whole data frame using the correlation function, and you can plot the heat map. So heat map directly gives that this picture is very correlated to this picture. So I can drop this picture. So here one example is given of the flight data. So year and month is given and passenger numbers are given. So by the pivot table or the correlation chart, you can have this pivot table. We already seen the pivot table. You can use the pivot table using the year and month as an indexing column and value as a passenger. Month is considered as a category, year is also considered as a category, passage is considered as a value. So pivot table is give the whole information in this 2D power. So it's mostly containing the numbers. And if you plot these, is also automatically give the correlation that you can see that in the July and August. So basically this data is from somewhere in Europe or something. So in the Europe, July, August is mostly the vacation time. So in the vacation time, the most of the passenger is traveling. So you can see here from this data, directly in a heat map, you can directly deduce that, okay, this is the peak time. Same way, you can have a cluster map. It will give the relation between the close that July, August is close in a cluster, single cluster. June, September is a close in a single cluster. These all are this as per the value of the passenger relation. It will create the cluster, whole data in sense of the cluster, and you can have as per your analysis. If you want to do some analysis for, let's say, you want to cluster that we want to observe the data when the numbers of passengers around 500. So you can check that cluster and you can do the data analysis on that particular months or the years. So this is all about the data analysis and the data, how do you data represent, how you do data cleaning and all things. So somewhat be clear about all the part of data science, basic science. Once you have a good data, then depending on your application and depending on the requirement, we mostly use the machine learning and the deep learning. So in the most of the scenario, when we do the data science, not the research in a deep learning and the machine learning is a different part, because you have a complex data structure. Data structure is following a different distribution, and your cost function is not a simple error that your cost function must have some regularization terminology or something. So you have a user defined cost function, and you have some user defined the data processing method. Let's say let's say you have very large amount of data and very large amount of features, so you first process the PCA and then you do something on that data, principal component analysis and all. So that okay, but we in normal data science, this library is providing all the functionality related to machine learning and data learning, like SQL and TensorFlow, which we are going to discuss. Also, you can have a custom functions in a TensorFlow. So for the research purpose, you can explore that part also. So first we discuss the sklearn library. We just take one simple case of the machine learning linear regression. So I created some data. Let's say I create some random sample, uniform distribution 1,000 samples. Then I created random normal distribution sample of 1,000 samples, and I created C is equal to A plus B. So I consider these three features. So from the creation of the data, you must have considered that, so okay, you are creating a C from the A plus B. So there is no new information in the C. But let's say I create the y is equal to b plus a plus c, and plus I added some random noise. So data is never clean. Some noise is there. So I added some random noise in this, and we have this as a label. So my y is a output, and ABC is a feature. So I concate this, and I created this shape, and I create the data frame using this. So we have this as our machinery data. So you can consider ABC as a feature and Y as your label. Not a label. In a regression we have a real value, so we have a output here, and we want to fix the y is equal to some ax plus by. So ABC is I given, so we want to fix y is equal to theta 1 a plus theta 2 b plus theta 3 c plus some intercept theta 4. We want to fit that linear regression. Okay, so before that doing, we must have a linear analysis, data analysis. And easiest way to do linear analysis is a pair plot. So when I do the pair plot, as diagonal part will give the information of the distribution of the each feature. You can see that C is a very thin relation. C with Y is a highly correlated. Yeah, it's okay. But C is correlated with the B. C is also correlated with the B. So we see the important means if the C sharing is so much information, more information than the B, then we can have that. On the some part like this, but C is not sharing so much, so it's varying. So we can see here a highly correlated C is highly correlated with the B. Let's see, we do the heat map. So in the heat map also it show the correlation that C, B, and Y is correlated, and we can see here. Now I will take some minutes break. I have a sorry. Sorry about the disturbance actually. So in the heat map diagram also you can see the correlation is highly. So in the SQL library, you lot of functionalities inbuilt, machine learning functionality like the linear regression, logistic regression, support vector machine, some of like the unsupervised KL transform, like with the PCA, principal component analysis, K-means, KNN, all things, decision tree, random forest, every functionality is available in this sklearn linear model. sklearn is not linear, but sklearn libraries contain this all functionality. And if you have a data, then you can use the Panda to do the analysis and do the cleaning of the data. Once you clean the data, you can have sklearn library to perform the operation, and you can always check with the comparative operation. So for this case, we use the sklearn library and use the trace split. So whenever do the machine learning, we must split the data in a two part at least, taste and trend, so we can have that how our model is performed. So the data can directly traced by the 10 trace split, and you can see the trace size is 0.4. So it's automatically depending on the provided size, but it will segment your data in a 10 and trace part. So in sklearn on the TensorFlow, you can have define the whole function as a model, as an object-oriented programming support. Your whole function is a model. So model is just a name. You can provide any name. So I use the model as a linear regression. Some of you may think that I want to use the SVM, so you can fetch the SVM from this and use the model is equal to SVM. You can feed that depending on the type. You just need a single line code to feed the model. So linear regression is fed by the single line, and it will give the output like model rate intercept. Intercept is we consider as a bias, and coefficient related to our features like A, B, and C. So it's a 0.6 multiply A plus 0.6 multiply B plus 1.3 multiply C is plus intercept is equal to Y. This is the our model output. So now we can use this model coefficient to predict the data. So model predict function is there. So you simply input your X stage data inside that, and you can have a simple predictions for that. And you can plot the test data, original test data with the prediction, and you can see that your data, taste, and prediction is match or not. So you can see is a pretty much match. Now, as I said, that this is so. Any doubt in this, you can ask me. Right? We can have some discussion for machine learning if you want, and we can have. You can turn on your mic and you can ask me anything.
You can raise your hands and then we'll unmute you.
Yeah, that's also. Okay, then I will continue after session. We discuss something. So now I already say that C is highly coded with the Y, but C is also coded with the B. So what? Let's say what happen if I drop the C. So if I drop the C, I consider the data set as a A and B only, and do the all things X and Y. So I okay. But here this function is implemented here. This is our code part. This is implemented, and this is. So you can see I am considering only A and B and doing the same repeat process, train and test. Again, it define linear regression model is used, model fit, model prediction, and we see the prediction. No change in the prediction. So we get the same accuracy using a two feature only. So that way you can do the data cleaning and cleaning. If some features are noise only, it's just a random garbage value with a very small standard deviation. You can neglect that. Let's say if you have categorical data and categorical data, and if you want to do the analysis like the classification. So we consider generalized data like iris data set, which is mostly is a flower data set. It's based on its feature, what features are there, and its species are defined. So these are the category. You can directly apply the logistic regression using sklearn. So pair plot, you can use the pair plots, and by pair plot you can also, if you provide the hue as a saturation, sorry, hue as a pet species, you can have the distribution along with the third dimension that this length of the sequence is the more in the case of the Sentosa, but in the less in the 2K. So you can directly also do the data analysis from here. And if you want to perform the specific task that you just only want to detect the Sentosa, then you can consider this as a your primary feature, and you can neglect the other feature to classify. So likewise, you can think from the pair plot, and you can use the logistic regression. Again, the trend based rate is used. Model in logistic regression, you can feed the data, and you can predict, and you can directly have the metric of the like the precision we call F1 score and the accuracy directly. So you can see we have a good accuracy using a simple logistic regression. So these all things can be done by the library. You can do this using the NumPy and Python, but you need to write at least 50 or 60 line code for the gradient descent algorithm or something. But if you have used these libraries, it's very easy to perform the machine learning and data science tasks. Okay, now we go to the TensorFlow library, which is also very popular library. Earlier TensorFlow is used the graph structure, and means graph structure means you define your whole algorithm part in a different tree that you are going to perform this tensor multiplication, this tensor multiplication. So very difficult language TensorFlow in earlier days, like in the 18 or 19 before TensorFlow 1.2 version and all. But Keras is a very easy library. Now the TensorFlow and Keras are merged, and TensorFlow 2 is a very easy library. So I took one data set of the high data set from the data set TensorFlow library itself, and you can see this data set is containing the information is a 28 cross 28 bit 28 cross 28 image along with the labels labels that is a 5 and all. So you can have that data. You when you want to perform your custom data set, then you need to make the data placeholder. So data placeholder is one of the functions of the TensorFlow. You can explore. It's very easy. You can directly take your data from the CSV or any, let's say you have data in a mat file, then also you can explore as a TensorFlow. As a placeholder, and you can take their data. The placeholder is already ready-made, so I took that. So you can see here its label is a 5 and its image looks a 5. Now, if we want to simply train this in a sequential model, deep neural network, if I want to train, so I let the 20 equals 20 as the first layer, then I use the second layer as a non-linearity ReLU, then I use some dropout function, and after that the dense layer 10 is there, so it will give them a 10 values, and after the sparse categorical cross entropy, from this 10, we can have a automatically label, because we have a label also, it's a like simple 0, 1, 2, 10. So this is a model. So in the model here, you didn't provide any machine learning part. In sklearn, you didn't provide any loss function. So if you want to have a machine learning or any deep learning algorithm, custom machine learning deep learning algorithm. So what the custom in the algorithm of the machine learning is the loss function. You define your loss function based on your cost function. Based on your regression part and whatever thing you want to cover based on your data distribution, you can define the loss function. So you need to create the custom loss function here, and you can use. So here we don't need any custom. We simply want to categorize the data. So sparse categorical cross entropy is a very good function. So loss function is also. Then you need to compile this model. So optimizer is defined the Adam optimizer. It's a modified gradient descent optimizer with the 2 moments. So it converts very fast. In the loss function, you define this loss function. And the metric is accuracy. So model is compiled using these functions. And when you perform the model.fit, it's automatically train the data, and it will give the accuracy, training accuracy. So once the model fit is there, then model have a weights. And if you want to evaluate in the test data, you can simply have model.evaluate x.test, x.y.test, and you can have your accuracy for the test data also. This give the accuracy 0.9788. So it's now train accuracy, test accuracy is done. If you want to predict your data, this all you can expect as a add to file or some other file formats. You can also have in a numpy array. You can also have the bits, and you can implement in your JavaScript and whatever you want for the implementation. Because once you do the machine learning, you need that weights to implementation or deployment. So the deployment part, the TensorFlow is a very good deployment support. So it will give your weights in a various forms, and that weights can be used in a JavaScript or different Android app also you can use nowadays, and for the performing the operations. So predict function is basically predict the test data and it's give the prediction. So now we have all the prediction for our test data. So we check that it's how it perform. I am show x.test.5. So it's looks like a 1, and you can see it's a 5. If you see the prediction, y test is 1. So if you see the prediction is a 5, then we have a 10 value. Model have output is a 10, 10 output. So it's basically dense means a sigmoid. So it will give 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, all the digits. So you can see highest value you receive at the 1. So you can use the RMAC function and directly you can predict them. So this is a small example of the digit classification or the data classification. And if you want to convolution neural network, because this is a image data, so you can use a layer.cnn2 here for the deep learning and all. So that's it, guys. I started from the basic Python, and I want to conclude here till the deep learning. Yes, I covered some of the important parts, not all the parts, but some essential part I given. So you can consider this as the initial start point, and you can explore each library. Even I don't have exploit. I explode, but I don't have exploit all the libraries. As per your functionality and as per your requirement, you can always search that library. All the library have very good documentation online. You can always find the functions. But these are the minimal libraries which you require for the data science, natural language processing, computer vision type of task. Even reinforcement learning and all you can implement. So I will conclude my session. Any questions?
So yes, so if anyone has any question, please feel free to raise your hand. You can also type your questions on the chat box. Any questions from any of our participants?
I have explored deep learning and data science in remote sensing area, like the hyperspectral imaging, and I have a little bit explored the computer vision using a deep. So to have rather
That's
than
great,
just
sir.
programming, you can ask me. So if I know, I will share my.
Yes, sir. That is great. Please raise your hand if you have any questions. Okay, so I think we don't have any question from our participants. So, yeah, we have received a query from Gagan sir. Let me just unmute you. Yes, sir, please go ahead. Gagan sir, you can ask. Sir, we are unable to hear you. If there is some problem with the audio, you can you can also type your question on the chat box.
Dr. Gagan has sent his question in the chat. Which plot is best suited for text detection?
Text detection. Text detection. Okay, so I haven't explored the NLP programming, but as per my means, you can have some categorical plotting uh, can help. So most of the you can explore the Seaborn library for the text data. So in the Seaborn library, if you want to, in the most of the time in NLP, what we do, we convert our data using some embedding or encoding. So you can encode, embed your data in some values, and then once you have values, you can use the pair plot even or something. So you can have some correlation with the because you if you use the same type of embedding or encoding for the word embedding or some encoding for converting your natural text data in the values numbers, because ultimately we are operating on the numbers. So that have a same mechanism. So what happen if you consider that value to the plot? Let's say your text data have a different categories, and so if you plot that, so you may find the relations between them. But the case is in the most of the case the data is sequential in the text. So if multiple categories there, then it's okay. But if your data is sequential, then you need to do analysis in some Windows basis. Means using some sentences you can consider like the stop signals and all, and you consider that how is related to that sentences are how is related and how they are closing. So mostly maybe I'm not sure. I'm just sharing my intuition, but mostly you can have some kind of this in your like the clustering type of clustering type of map. Let's say you work on the hate speech detection or something. So your data must have some keywords. That keywords are occurring the multiple times in the hate speech or something. So you can convert that words in the values, and that values depending on that you can create the cluster map. These words are created nearest. So you can have some analysis that okay, so this cluster mostly represents the hate speech and this cluster is representing the normal speech. So you can have your various technique based on your intuition, but just do the analysis for the text. You must, as per my knowledge, you must go to the in the values and numbers. Once you got in numbers, you always use the C1 type of library have the correlation plots like the pair plot, or you can have the clustering type of plot for the data analysis. Any other if you want to ask?
Yeah, can you please add something about detection of hate speech? One of the participants has asked this in the chat.
Okay, so basically in a detection of the hate speech, as I already said, I am not from the NLP, but I have seen some of the undergrad projects for the hate speech detection or the hate speech detection. So basically, attention mechanism is the most famous nowadays. So basically, attention mechanism is put some attention to the particular keyword. So what we can say that we have a numbers of words, and basis on the information provided by that word, we have some attention mechanism. You can have some weight type of structure. There are various neural networks are available for attention mechanism. So attention mechanism is also used in computer vision for the normally it's computer vision for an NLP, image captioning, automatic image captioning. So from the image automatic captioning is created. So they just give attention to the most important part in the image, and they provide to the that sequential network, which is your RNN or the LSTM network. In that, they provide some different type of states which can take care of the attention, and they provide the weight to the different states. So you need to explore these things, but attention becomes a very good, good till now, as per my knowledge, good mechanism to have a very good hate detection, and it's a to categorize the text data like the sentence text data. So rather than just considering the simple text and considering some important words and converting the value, if you also infer some information from that the hate in the hate speech, this word, particular word like a bomb or something, or some word is very very important, then you provide the attention towards that word, then it will help in the meta classification. So you can serve some attention mechanism paper in NLP. So I am not from the NLP, so I just gave some of my intuition and some of which I discussed with some of the undergraduate students.
Yes, sir. Sir,
Yeah.
one of our participants is asking your email ID.
Yes, yes, you can share my email ID. jigneshpatel.csc@charus@ac.
Uh, okay, sir. Sir, can you please type in the chat box?
So I will stop sharing now, I think.
Sure, sir, sure. Thank you so much, sir. So, on behalf of Indira Gandhi, Delhi Technical University for Women, I, Sakshi Patel, would like to take this opportunity to express my heartfelt thanks to Jignesh sir for such an amazing session. Thank you so much, sir. Dear sir, we are very grateful for the time and effort you took to share your thoughts and experiences with us. We have learned so many new things on Python today from you, and we look forward to learning more. We hope you can join us again. And once again, thank you so much for the highly inspiring time with us. Thanks to the whole audience for your unwavering attention throughout this session. We look forward to having you again in our next session. Thank you so much, sir, for such an insightful session. Thanks a lot, everyone.
Thank you all, and thanks organization for inviting me, and gave us such a good opportunity. And I am very glad that you are considering me with Alad Kumar and Ashish Pakuda sir like that, because I learned from them at my PhD career. So yeah, it's a great opportunity for me, and I also have a very good experience. Thanks a lot for inviting me.
Thank you, sir. Thank you so much, everyone.
So I'm going to leave now. Thank you all again. Anything else from the organization team? Okay, so I'll end the session.
Yes, sir. Thanks a lot, sir.
Good afternoon, everyone. We are waiting for our speaker to join and we will begin shortly. Thank you. Good afternoon, everyone. Bala sir, can you hear me? Hello.
Yeah, I think somebody muted me. Yeah, fine. I am hearing you.
So you can share your screen now.
Okay, shall I
And
start the
please,
presentation?
please switch on your video as well. Thank you. Good
Video
afternoon,
is
everyone.
connected.
Sir, your video is not visible.
Yeah, please go ahead. It's fine.
Good afternoon, everyone. Myself, Anushri from Indira Gandhi Delhi Technical University for Women, will be hosting you in this session. For this session, we have Professor R. Bala Subramanian from Computer Science and Engineering Department, IIT Roorkee with us. Professor Bala Subramanian has pursued his PhD in Mathematics and Computer Science from IIT Madras. He has completed his MSc and BSc in Mathematics from University of Madras. He has more than 20 years of experience in teaching and research. His area of interest includes computer vision, optical flow and video analysis, fractional transform theory, multimedia security, biometrics, content-based video retrieval, video skimming and summarization, medical imaging, long-range imaging, and machine learning. He has authored several books and over 100 research papers in reputed international journals and conferences. In this session, Professor Bala Subramanian will be discussed about application of machine learning or deep learning in vision and imaging. So I request Professor Bala Subramanian to address our audience.
Thank you, Dr. Anushri. I'll share my slide.
Yes, sir. Please. Sir, your video is also not visible.
It's 2 hours, right?
Yes, sir. It's up to 4:30.
There is some technical problem. I'm just. WebEx is always low.
Yes. We can see your screen now.
Huh?
Sir, आपकी screen visible है. We can see your screen now.
Screen is visible, but problem is I don't know.
When
So how many participants are here?
Sir, around 83 participants has joined. Yeah.
Sure, what is happening here because of this WebEx.
It's taking a lot of.
Make PDF and do that. I don't know. So why PowerPoint? I took class.
Setting is to column. So we can do one thing, that if you share your presentation, Nidhi ma'am, then we can share it on your behalf.
No, it's coming. I don't know. It's slow. It's due to this
It's taking time.
WebEx.
Mm.
WebEx is creating a problem. We usually avoid WebEx. We use Microsoft Teams.
Yeah, it's better than.
Hopefully it will work. Yeah. Sorry to everyone. Good afternoon, all. I hope my slides are visible. Anushri, can you confirm?
Yes, sir, your slides are visible.
Okay. Thank you. So I thank Dr. Anushri for the brief introduction. And I also thank Professor Riddhi, who is my PhD student at IIT Roorkee long back. And thank you, Riddhi, for giving me the opportunity. And in this talk, I'll talk about the applications of machine learning and deep learning, but I have to say and, in computer vision and image processing. So I'm a professor in the Department of Computer Science and Engineering, and also a joint faculty at the Center for Artificial Intelligence and Data Science at IIT Roorkee. And in front of you, I'm showing our majestic building called James Thomason Building. I hope some of you might have visited IIT Roorkee. In case not, you are all welcome to So organization of my lecture goes like this. So we'll see the brief introduction on machine learning, data science, even deep learning. And then I'll talk about few applications on brain-computer interface, human action recognition, sign language recognition. All these applications you'll see in deep learning as well. And then I'll end my talk with applications of the combination of the cloud and deep convolutional neural network. So when we talk about the machine learning problem, you will have the two important features on it. One is how you are going to extract the features, feature extraction. And the second one is the classification. All right. So the classification goes like supervised learning theory, supervised learning, unsupervised learning, reinforcement learning, and so on. So these three are the major ones. So what do you mean by supervised learning? Supervised learning is like, for example, suppose a robo is there and you are asking the robo to classify the fruits, right? Truck of fruits. So the fruits, let us say you have apple, banana, grapes, oranges, etc. Right? So we are giving the information, right? We are annotating it based on the shape, color, structure, right, etc. So now let us assume that nearly 80% of the fruits are being, 70% of the fruits being trained by the robo. So we are giving a train. So then the robo will classify based on whatever it is learning rest of the fruits. We call this as a supervised learning. So now assume that we are not giving any information, but it will learn itself the help of again features like color, structure, right, shape, etc. Right. So if it learns by itself and then it knows how to classify, we call it as an unsupervised learning. And the third one is reinforcement learning. Reinforcement learning means, suppose assume that a monkey is there. All right. So we are giving a gift. So if it does the job correctly, so right, we are giving some set of jobs. So if it does the job correctly, we will give banana as a gift. Right. At the same time, if it does the job wrong, right, wrongly, so we will give a beat. So in the process of gift and beat, or we call it as a gift and punishment, the monkey will start doing the job correctly. So we call this as a reinforcement learning. Right. So in this talk, we will see several supervised classification, unsupervised classification, and we'll see how these learning theory will be applicable in deep learning algorithms. So first I'll talk about the brain-computer interface. Right. For this smart house, right, nowadays all are hearing about the smart house. So in which you can control everything by, let us say, a remote. Whereas in another 5 to 10 years down the lane, all right, suppose I'm entering this house and I'm thinking, okay, the AC is running, let us say 27 degrees Celsius. And I'm thinking I want to change it to 23 degrees Celsius. I'm just thinking, right? So can it change? And similarly, a movie is going in the TV, right? I want to change to sports. I want to watch cricket match, right? I'm just thinking. So can it change? All right. So this is called brain-computer interface. Right. So whatever you are thinking, right, the signal emits from the brain, will it be converted into, right? So whatever you like, right? So whenever you are thinking something, so there will be some signal. So can we capture this signal by a device? And then whatever we have captured the data, will it be converted what exactly we want, right? So that is called brain-computer interface. So in order to do this, so we can use electroencephalogram. So the electroencephalogram EEG device, right? The EEG device that you are seeing here, it has 14 channels, right? Everybody knows ECG, electrocardiogram, right? So ECG measures the heart rate. Similarly, EEG, so that can capture the signals from the brain. So now here you are seeing 14 different channels. This is a device with the 14 different channels, and round in shape is called the electrodes. All right. So our brain can be divided into, let us say, 4 parts, exactly like a heart. Right. And then we place this, right? We place this apparatus, right? This EEG apparatus in our head, and these electrodes, the round in shape, right? They are responsible to capture the signal. Right, our signal can be captured like this. The diagram that you are seeing over here, the brain is divided into 4 parts, and we can get the signal, right, from these electrodes. Now you can see some of the devices, right? So here you can see some of the devices. It's called the EEG devices, where you can get the signal from the brain. Right? So in IIT Roorkee, we have the device, that EEG device, right? So the signal, analog brain signal, will be converted into digital one, right? So for this, we require both hardware and software, right? So we got this from a company called Aerobe, right? So it has the first one. I gave an example of 14 channels. So here you can have 160 channels. That means 160 electrodes. So the number of electrodes are more, the signal will be good, right? So this is a specification of the device. So it's a 24-bit amplifier. We can have 32 to 160 channels. We can use the 32 electrodes up to 160 electrodes. The rest of them, I'll share the slide. You can read what are the specification of this device. So this costs around 75 lakhs or even more in Indian currency. Suppose you want, let us say, the wireless one, right? So whatever you are seeing, it's a wired one, right? So suppose you want to the wireless, it is costing nearly 1 crore or something. So slightly the costlier objects, costlier apparatus. So here we will see some of the interesting results what we got before, and I can give you some idea how you can work and improve in this area. All right. So one such work is the prediction of advertisement. Right. So suppose you are given, let us say, 20 different songs from YouTube. Right. So you assume that you can even have 100 songs, but we start with some very less number of data initially, right? Number is less, but when you are looking at the data, the video data is slightly huge, right? So we use some persons, some subjects, to hear the songs, right? And then we take the feedback both in a paper as well as with the help of the EEG signal. All right. So this EEG signal from the brain, suppose you are hearing the songs, right? Different songs. So the song may be excellent, it may be very good, it may be good, right? Fair, or maybe poor, right? So like this, assume that we are dividing. You can have more number of parameters. Assume them, right? So if the song is really good, yes, your mood will be really good. Whatever signal we are getting, let us say we have to analyze. So these signals will be generated by electroencephalogram, EEG. And similarly, the same person has to give a sentiment data. Sentiment data in the sense you are giving like a feedback. For example, after this lecture, you may have to give a feedback, or after when you're teaching, your students will give a feedback, right? So we call this as a sentiment analysis. So now we have two models. One model is from EEG, another model from sentiment analysis. So now we call this as a bimodal, right? So we are integrating these two data. We call it as a multimodal. So we have EEG data. You do feature extraction and classification, the machine learning algorithm. Similarly, sentiment analysis do feature extraction and classification. So it will be like right in the election, you are using this EMI, right? Electromotive voting machine, EMV, electromotive voting machine. All right. Similarly, like a ballot paper, also you are doing the vote. So now what will happen? So suppose you are calculating all the votes using ballot paper, and then you are comparing this with the machine. So whether the votes are matching or not. So in a similar way, so here you can either use using the data, or also since you are getting from the sentiment analysis, that means the feedback data, we can compare this with our EEG data. All right. So all these purpose it will be useful. So in this case, what we have done, we have compared. So for example, you will get a score from EEG, right? Let us say alpha, and from the score from your sentiment analysis, let us say beta. So put some weight, alpha into W0 plus beta into W1. So we'll give you whatever be the highest score will be considered as rank 1. Right? Or even otherwise, you can compare whatever EEG data will give the results based on your machine learning algorithm. So you can compare with your feedback results. Right? So in general, these kind of problems will be called as a multimodal fused data. So now from the YouTube, let us say 20 different songs are there. Our focus is to classify all these songs. Right? Classify in the sense our focus is to rank these songs. I'm sorry. We have to rank these songs. So 1, 2, 3, etc. So it will give a rank. Right? So whatever be the score, highest score, alpha into W0 plus beta into W1. So whichever be the highest score will be considered as rank 1, rank 2, etc. Right? So this is how the applications of machine learning come over here. These kind of brain-computer interface problems are very much useful. So now, when you're getting a data, EEG data, you look if you look at the EEG data, it's a one-dimensional signal. All right. So here, if you look at this, the second column, so there are some green part, there are some red part, right? So we divide to violet to red. So the red is indicating, for example, I cannot use the second data because the signal is very poor. All right, and the score is 5. Higher the score is, poor the data. Right. So for example, if I use the fourth or fifth data, even the first data, we are getting some signal, right? The green in color, the rank is 2. So 2 is better, right? So we have to think of how we are getting the data. So these data are from 14 channels. If you increase the number of electrodes or number of channels, your data will also be good, right? The quality of the data will also be good. So the next concept is you have to remove the noise from the data, right? Whatever data, whatever EEG data that you are getting, so you have to remove the noise. So for this, we used moving average filter and independent component analysis to remove the noise. So suppose you are, okay, I'll use a pen. Suppose your signal goes like this, right? Let us assume that your signal, given signal is this. So we have to convert, we have to remove all the noise, and then our resultant signal should be like this. So now for the input, I have to use this signal, right? For analyzing the problem, I have to use this signal. So this means this, yeah, I have removed the noise, and then the smooth signal will be right. So now, as I said, it's a multimodal problem, but most of the, let us say, data mining researchers, they use sentiment analysis. Suppose you want to rank all these songs, so you might have seen several research papers, right? They got the feedback. From the feedback, you can analyze, right? For example, if it is a binary class problem, like a positive sentiment and negative sentiment, all right? So you have to pre-process the data, train the data, extract the features, apply some classification algorithm to get whether it is a positive data or a negative data. Similarly, even if it is 5 parameters, right? If there are 5 parameters like excellent, very good, up to poor, right? So we have to train the data and get the output, or simply use a statistical model. Right? If you're not comfortable with, let us say, machine learning algorithm, use some statistical analysis, multivariate statistical analysis to get the output. But here in this case, we have combined both EEG data as well as sentiment analysis to get the output. All right, so this is how. So in both the ways, right? Suppose I use, let us say, EEG and sentiment analysis, I'll get the output, and whatever be the score that I am getting, so we use some weights, W0 and W1, and alpha into W0 plus beta into W1 will give the resultant output. So this is one such problem. Similarly, if you look at this title, don't just sign use brain. All right. So nowadays, in a banking sector, suppose A is the original genuine signature, right? B is the forged one, right? Assume that if somebody is doing like B, transaction can be done, correct? So now, how to use the brain signal as well? Not only signature, how to use the brain signal. So, for example, we are collecting the data during the signature, right? Suppose a person is depositing, let us say, 500 rupees, 1,000, 10,000, right, up to 100 crores. Assume that. So, in different scenarios, assume that, all right, so we are taking their signature as well as their EEG signal during the signature. All right, so we put everything in a database. Right. So now you have various cases. So various statistical methods you can use. You can use the common one, or for the different scenarios you can use the different one. Again, it is a multimodal problem. Right. For example, somebody is assume that you have trained the data. Right. Assume that you have trained the data. So now I am going and then depositing or withdrawing, let us say, 1,000 rupees. So now, along with my signature, we have to match with the EEG signal, right? So right now, the EEG apparatus is very costly, right? Maybe who knows, another 5 to 10 years. So even you can put this apparatus in your mobile, right? So it will go like that, right? So we know earlier in the 1960s, so 10 MB hard disk, it's very huge, right? You might have seen in the social media, right? So now you are putting everything, even a terabyte of right, hard disk in your pocket, right? So this is how the technology have been developed. So after few years, so let us say 5 to 10 years after, so even these EEG will be in your mobile, right? Yeah, it has its own disadvantage as well. But so whatever you are thinking, for example, assume that I got one email, right? I got one email, and I'm thinking I want to reply this. So from this device, that EEG device, assume that, right? I'm talking about next 10, 15 years. So it will be in your mobile or whatever device that you are using. So whatever you are thinking for the reply to that email, so that will automatically go, right? So the technology will develop like this when the brain-computer interface, right, develops. So now the idea is when I'm signing during my signature, so my EEG signal will also be taken, right? And then let us assume that it has been trained for various cases. And suppose I am the user, I will go and sign. During my signature, again during testing, the EEG signal will be taken, and then whatever be the the result and whether you are a genuine person or not will be decided. So now again it is a bimodal problem. We are using, let us say, the signal, EEG signal, as well as the image database. The image contains all your signatures. So now, as I said, when you apply the machine learning algorithm, you have the signal, right? So you have to see the features, right? You have to extract the features. So for here, we have done with the help of, let us say, wavelet transformation. With the help of wavelet transformation, so wavelet transformation, you were given original signal in the frequency domain, all right? So it will be divided into various levels. Level 1, you have approximate part and detail part, right? So level 2, again the approximate part of level 1 will be divided into approximate part and detail part. It will go, right? If you look at the tree structure from the left skew, if you look at the left skew, it will go like this. So this is called wavelet transformation. So here, in a way, various levels, I find the wavelet coefficients. So that means I'm extracting the features. So when I talk about the fruits example, the robot can classify based on the features, right? Color, shape, structure, right? Texture, etc. So here I'm extracting the features from the signal, right? Let us say a level 4, it is alpha. Level 3, it is beta. They're all wavelet coefficients. So these wavelet coefficients are features. For example, I am signing. So during my signature, let us say my signal is there. So the signal will be captured. Correct. So the signal right will follow different signals. So different persons will have, let us say, different signals. So different signals will have different features. So for my case, I am finding, for example, I am the user. For me, so it will be alpha, beta, gamma, and theta. Right. So these are all the features. So similarly, let us say 100,000 users are there. So you will have the features. So you are training. So during training, I mean, you will get all the features in terms of alpha, beta, gamma, and theta. So now during testing, right, again you will get this alpha, beta, gamma, theta, and then you have to do the classification. Correct. So for this, we need some classifier. We'll see. So since it's a bimodal data, we use the discrete wavelet transformation plus Hidden-Markov model for brain signal, and pyramidal histogram plus Hidden-Markov model for signature, right? PHOG. PHOG stands for pyramidal histogram of gradient. So you have a signature. Correct. Signature is in the form of image. So I'm extracting the features from the signature based on the pyramidal histogram of gradient. And then for both, I am using the classifier called Hidden-Markov model. So now it's an initial stage of work at the time. So we use 70 subjects, right? 40 males and 30 females. So this data has been collected, and you can see the age distribution as well as the number of participants. So the first one is the original signature, the corresponding brain signal. Second one is the forged one. Third one is the original signature, but fourth one is the forged one. But even though this signatures are matching somewhere, so we can see the brain signal is completely different, right? So we discuss with various cases. So suppose, for example, the signature is completely different. All right. So we no need to go for the brain signal at all. All right. So we can use our bimodal concept like this. All right. So similarly, suppose the signatures are matching. Right. Both the signatures are matching. The original, the genuine person, and the forged person. So now we have to go for the brain signal. right? We have to go for the brain signal data. So in that case, if it is completely matching, right? So then we can say that the person is genuine, otherwise not. So we have tested with the various cases, and at one point of time, you can see the accuracy that we got is 98.24%. So this is all about the brain-computer interface. If you have any questions, I'll just answer before going to the next section. Okay, yeah. If you have any questions, you can ask. So am I audible? Some students are
Yes,
saying.
sir. Yes, sir, you are audible.
Yeah,
Do we have any query from participants? Please mention your query in the chat box. But till now, we don't have any query.
Okay. So if you have any questions, you please type in the chat box. So the next application is the human action recognition. I think yeah. So the human action or activity recognition. So for example, we know that the video data is a very big data, right? Very big multimedia data. So suppose I am looking for something in, let us say, the CCTV footage or a PTC camera, right? I am looking for some person, or there may be a fight, right? Which would have happened, let us say, some time frame, or you are focusing on some person, or there may be a chance that the person is running, or he or she is using bike, right? So I want to separate it out. So assume that the data is, let us say, 24 hours data with you, right? The given 24 hours data, I want to look the person. Maybe the person may appear 4 or 5 times, 4 or 5 frames. All right. So in that case, how to do that? Manually, if you do, yeah, you will lose most of your time in your life. All right. So can be automated. That is what the idea of this problem. So which is called as the human action or activity recognition. For example, here you are seeing 3 different videos. One is a RGB video. The second one is a depth map. And the third one is the infrared video. So here I am looking for the human action or activity recognition. So for example, the RGB video, a person is hitting the ball, right, throwing the ball, hitting the ball, and collecting the ball. And in the depth map, we are not able to see the person, but he is doing some action, right? And the third, there are several activities are going in the night, right? So some activities may be illegal or not good. So can we determine these actions for different input, right? Different model or different data. So is it possible to use a machine learning algorithm to find what exactly the human action or activity you want, right? So these are the levels of human activities. So you can see the gesture by a person. Second one is action, right? He's doing like a tennis stroke, like walking, waving. These are all actions. And the third one is the interaction, which is called either human-human interaction or human object interaction, right? Like shaking a hand or texting, all are called the interactions. And the fourth one is the group activities. So it may be violence, it may be a fighting, or it may be stealing in ATMs, right? So these are all called as the levels of human activities. So now we will talk about the human action recognition. So assume that you are given, let us say, 12 different video, right? So we know that video is a very big data. Like a second, you will have some 100 frames in a second. So assume the 30 minutes video I am giving. All right, in a second you have, let us say, 100 images. Imagine how much you will have in 1 minute, how much you will have in 30 minutes, or even 1 day. All right. So here we have been given 96 hours video, and moreover 12 different cameras, not only one camera, right? Such a huge or a big multimedia data. So now in this parking lot, it's a parking lot video. Assume that in the parking lot we have a CCTV footage. So here in this data, we have to find out in this parking lot what are all the human action is being done. Right? For example, set of people may walk, right? They may run, they may fight, right? So these action we have to find. So initially, with the help of mosaicing, image mosaicing, we are finding the common area. And the common area look like this. So in this common area, what are all the human action is being done? Right. So for example, people may walk. All right. So in fact, here in this case, you are seeing only walking, but people may run, people may fight, people may punch. Right. How do you extract? So for this, suppose if we consider the consecutive frames, you are seeing one frame, assume that in the next frame. So the person whom they are walking that you are seeing, right, in the next frame, you will find the background, right? Maybe next frame itself, you may find. That means I'm talking about the change of color, change of gray level value. For example, the cars are static, right? So what will happen in the next frame? They will be same. So if you look at here, the algorithm is called optical flow algorithm. I can extract only the moving objects. We call it as a dynamic object. Because the next frame, the gray level value will change, right? The color will change. For example, assume that a person is wearing green in color. In the next frame, the color may be green because the background grass green in color, right? So now I am trying to extract these dynamic objects. If you look at the black, which is static object, and white is a dynamic object. So I make it as a binary. This is called region of interest or silhouette extraction or finding out the binary image. All right. Now we talk about the action, human action recognition. So assume that suppose I could extract the image, right, the binary image. So once I extract the binary image, I am going for feature selection, right? Because I don't want to use the complete data. I want to select some features because that is enough to work on these kind of problems because the data is huge, right? The data is big. So what we are doing, we will use skeleton algorithm, right? So that means you are seeing the image, and then if I am finding the skeleton of this image, right? So this data will take care the topology of the original data. Okay? So the original data, the original in the sense the extracted data here, so this may have thousands of pixels. So I'm reducing into tens of pixels. So that is what my idea of extracting the skeleton, right? Finding the features of the skeleton. So from the skeleton, I'm going to extract the features. All right. So for example, a person is walking, the feature is this, right? For example, apple, the features are red in color, right? Spherical in shape, texture is completely different from orange. So like this, we are finding out the features, right? So the feature goes like this. So this is the feature. So this is a feature for, let us say, a person is walking. So this may be different for running, right? Whatever features you're going to get, so that may be different for running, right? So now I use some classification algorithm. Let us say LDA3, LDA, SVM, neural network, right? Several graph-based, random forest. So all are classifier, right? So once you extract the features, so the classifiers will classify the action, right? So we are going to get the whatever the different actions, right? So that we will. This is the overall view. So for finding out the skeleton, we have used our own work, right? We have done skeletonization for 3D objects. So now you have extracted the features. The features are 2D image, right? So you have extracted the data. The data is a 2D image. So for this 2D image, So here we have used the vector space, right, or potential function. So for example, if I denote my image is, let us say, f of xy, right? So this is your image. So what I will do, I will partially differentiate this with respect to x. Right. Similarly, I'll partially differentiate this with respect to y. So now I can find a force vector. So the force vector will be, right, I of dou f by dou x plus j of dou f by dou. So my image, my digital image, mathematically I can represent. This is a digital image. Mathematically, I represent as f of x. So when I partially differentiate, I will generate a force vector. Right. So your force vector look like this. So this is your force vector. Right. So if you see the force vector here from the boundary, the vector is moving towards this direction. Right. And similarly from the opposite direction. And here there is a convergence point. They will converge here. So now my algorithm has to extract this one. My algorithm has to extract this curve line. Right. So that is called as a skeleton. So when my algorithm is able to extract this, we call this as a skeleton. Anushri, are you there? Actually, there is a power problem here.
Yes, sir, I'm there.
If anything goes out, I'll see. Otherwise, I have to connect with the mobile.
Yeah. Okay,
mobile.
sir. No issue.
If anything goes wrong, you have my mobile number?
Sir, I will coordinate with Nidhi.
Or coordinate with Riddhi. Sorry, Nidhi.
Yes.
Thanks. Okay. So the idea is you have to extract the skeleton. Right. So let us assume that once I get the skeleton, right? Suppose I get the skeleton, how my original algorithm works. Yeah. So once I get the skeleton, assume that using the potential function that I explained in the previous slide, assume that we are getting a skeleton. So now, once we get the skeleton, we use the bounding box called ellipse, right, to encircle it. Because if you use any other geometrical entity, it will occupy the unnecessary space. It will occupy the unnecessary space. The black pixel will be moved. So now, once I extract this, once I get this, I will divide this ellipse into n sectors. So now, let us assume that any sector, if you choose, assume that the second sector I'm choosing, I have to find out the number of pixels in each sector. So here you go, the black pixels. The background is white. The number of pixels in the second sector I'm calculating. Similarly, first sector, third sector, so on, up to n sectors. Right. So once I get this, so here in this case, let us say we are in the jth frame. So in the jth frame, I have n sectors. The sectors are 1, 2, 3, etc. up to n. So suppose f2j, right? So we have we have f2j here. So f2j stands for number of pixels in the second sector. So once you find the number of pixels in the second sector, you are dividing this by total number of pixels in the skeleton. So similarly, you do for first sector, third sector, etc. up to n sectors. So now for the jth frame, your fj is the future vector. So for example, you are given an apple, you know that the color is red or green. All right, that is a feature. So for jth frame, this is a feature. the feature is being defined like this. So suppose you have all consecutive frames, your features are this. The complete features are this. So now assume that your the person is walking, right? You want to see in the complete video what are all the frames the person is walking, what are all the frames the person is running, what are all the frames the person is fighting. So you are training the data and extracting the features like this. So this is called as feature extraction. All right. So once you extract the features, assume that during a testing, you have to classify. So for this, you require a classification algorithm. Right. So here, what we are going to do, we use, let us say, a linear discriminant LDA, right? LDA based classification. So initially, we will see how the linear discriminant binary class problem works. So suppose you have two set of data. One is red, another one is green, another one is blue. Right? So we have two set of data. One data is like this, another set of data is this. So now I have to do this classification using linear discriminant analysis, which is called LDA. Right? So assume that your class is being given. So which is, let us say, x1 and x2. One class is x1, another class is x2. So now my first step in LDA, I have to find out the mean. Right? Given this data, it's right. I'll come over there. So first, given these data, so we have to find out the mean. Right? So we have to find out the mean, mu1 and mu, which is not difficult. You use a simple formulation, 1 by n1 into summation of x. So given 2D points, you know how to find out the mean, which will not be very difficult. So once I find the mean, what I am going to do next? I am going to calculate the covariance matrix. Right? So the covariance matrix is being calculated using the summation of x minus mu1 and x minus mu1 the whole transpose. Right? So the covariance matrix S1 we found out, right? Based on the data you have calculated, mu. This is for S1. Similarly, you can find for S2, second class. Right? I will find out for S2. So once you find for S2, then when you add these S1 and S2, you call it as within class scatter matrix. Right? You call this as within class scatter matrix, SW. So now the problem is, suppose you are given, right? You are given a set of points like this. One set of point is this. Another set of points, another class will go like this. In this case, it is not difficult. You can easily classify. This is one class. Or this is a second class, another class. Whereas suppose the scatters is like this. So you have set of red points. And then you have another cluster of points. Cluster of blue points will be like this. Now I am asking you to classify this. All right. I have a blue class here. All right. And I have a red class here. So all are in the mixture. You have a red here. You have red here. Right. You have red here. Whereas you have blue also inside. So this is a blue. Or I put a dot. This is a blue. So for these kind of problems, you can solve. It won't be very difficult. But when the problem is of this kind, right? When the problem is of this kind, so what this LDA algorithm is telling, project this point in a one-dimensional line. So this is in 2D. This is in a plane. So project these points into the one-dimensional line. And what this LDA analysis is saying, in the one-dimensional line, suppose I have a line like this, right? My assume that I have a one-dimensional line like this. Correct. So in this one-dimensional line, my set of points. So I have set of, let us say, blue points. Assume that they are almost on the line, right? And then I have set of red points will be classified like this, right? So when I project this 2D point into this 1D line, my data will be classified like this. So this is what this LDA is saying, right? We will prove this. So now your set of data points are of this nature, right? We are dealing with this kind of problem. Now, when your data is like this, how do you classify using LDA? Correct. So we will avoid this. So if it is like this, the problem is simple, right? Several support vector machine or neural network, I can able to classify these classes. This problem is not very difficult. We are not focusing on this. We are focusing on this. Suppose the cluster is like this, even the binary class. So how do you project this into a straight line, and the classes will be classified? This is x1 and this is x2, right? So for this, we first calculate the addition of two covariance matrix S1 and S2, right? Addition of this S1 and S2, and we call this as within class scatter matrix. So we already computed this. Within class scatter matrix will be this, right? Then after this within class scatter matrix, using this mean, we calculate the between class scatter matrix, right? Between two classes, what is the scatter matrix? So we use the mean of both the classes, mu1 and mu2, and mu1 minus mu2 the transpose. We calculate that. So assume that that is SB. So we calculated SW within class scatter matrix, and we also calculated SB. So now with the help of this SW and SB, our aim is to find out the line that you are going to project all your 2D points. So for this, during theory, I will tell you why we are calculating the eigenvalue for SW inverse SP, right? We have to calculate the inverse of SW in what do you call eigenvalues of the matrix SW inverse into SP. Assume that we find out, right? Let us say the eigenvalue is one is 0, another one is 12.2007. So once you calculate the eigenvalues, right? Assume that I'll calculate the eigenvalues. So you'll find the corresponding eigenvector, right? So for example, for eigenvalue 0, this is your eigenvector, right? For eigenvalue 0, this is your eigenvector. And for eigenvalue 12.2007, this is the eigenvector, right? So now what we can do, since this is the largest eigenvalue, this is your largest eigenvalue, I will consider the corresponding largest eigenvalue. So you may ask the question, why? Why you are going for the largest eigenvalue? I will let you know. Graphically, I will let you know why we are going for the largest eigenvalue. Correct? So one way you know how to calculate the eigenvalues and eigenvectors. The other way you can compute, since you know the within class scatter matrix, you know the mean of two data. So if you use this formulation, you will get the eigenvector for the largest eigenvalue is this, right? So this is same as if you look at the previous slide. .9088 and 0.4173. So you got the same. So you use one of the methods to find out the largest eigenvalues corresponding eigenvector. Right. Now you may ask the question why I am focusing on the largest eigenvalue. Suppose I take the smallest eigenvalue. The smallest eigenvalue is 0. And let us say the corresponding eigenvector. Eigenvector is nothing but a line, right? The vector, you will have a line and magnitude and direction. So you will have a eigenvector of this, right, pink in color. So now I rotate this eigenvector along x-axis, right? So assume that this is my eigenvector, right? This is my eigenvector. So now I project all these points, right? For example, here I am projecting this red here, right? And then blue here, right? So since I have rotated this, you can see my set of data points. They are all overlapped. And I am drawing the corresponding Gaussian function. For these blue points, I am seeing the Gaussian function is this. For the red points, I am seeing the Gaussian function is this. But the problem is they both have overlap. So we call this as a bad separability. This is not a good separability. So the bad separability is happening because of we are considering smallest eigenvalue and the corresponding eigenvector, right? So now you can think of largest eigenvalue, right? Let us consider the largest eigenvalue. Now, if you look at the highest eigenvalue or largest eigenvalue, right? So we consider the largest eigenvalue, and you can see this is the corresponding eigenvector, this line, and then assume that I am rotating this to x-axis. Obviously, all the points will also be rotated. That is the assumption. Or if you look at, if I project these red point here, right? Already this is almost on the line. And similarly, blue points I'm projecting. Right? So if I rotate all these in x-axis, you can see red point is here and blue point is here. This is what I explained. We consider the data in the 2D. The data in 2D may not be separable, but here, if I find the largest eigenvalue and the corresponding eigenvector, all right, so these are all the points that I am projecting into the eigenvector. Assume that I am rotating all these points, right? I am rotating all these points in the x-axis or the axis, this axis, first axis. So you will have, after projection, I am rotating. So this is your red point and this is your blue points. And then the corresponding Gaussian function. So this is the Gaussian function for red point and this is the Gaussian function for blue points. All right. So they have been separated out. It is a good separability. So I have classified these two red and blue classes. So this concept is called linear discriminant analysis. I hope it is clear for everyone. Right? Suppose you have a binary class problem, right? So one example I had given. So suppose you have two different X-ray images are given, right? So one X-ray image is a normal patient. Another X-ray image, this person is suffering COVID-19, right? How do you find out? So using the features. So the bones are visible, right? No, there is no cloudy kind of structure there. The lungs are not much affected, kind of. Whereas here, you can see, right? It's a cloudy kind of, right? So the virus has affected the lungs like anything. So you can classify as a human, you know, this is normal and this is COVID-19. So now you have to train your data set. When you're working on these kind of problems, you have to train your data set, right? Extract the features. So whatever features I said, based on that, I know, we know how to discriminate, right? Normal and COVID-19. Right? So the data is available here. Maybe I'll share the slides and you will come to know that. And if you apply the problems like LDA, so this will be useful to find out the different classes. Right? So the theoretical point of view, we are finding out the eigenvector, right? We call it as a direction psi. We are finding out the eigenvector using SW and SB. SB is called between class scatter and SW is called within class scatter. So now the problem is to minimize, right? So you are minimizing the SW. So that means maximizing the direction psi. So this equation is called Fisher's equation, right? So the Fisher's equation he has given for analysis for the linear discriminant. So we have already seen all the notations we have seen. We know how to calculate SB, and similarly we know how to calculate SW, correct? So we know how to calculate SW. All these things we have seen, correct? And then if you look at the expression in the Fisher's equation, if you look at SW is in the denominator. So this is the reason we calculate the eigenvalues of SW inverse into SB. Okay, so this is the reason we calculate SW inverse, eigenvalues of SW inverse into SB. So once you find out the highest eigenvalues corresponding eigenvector, you are projecting, right? You are projecting in the eigenvector direction when you are calculating psi, the direction. So in this direction, when I project all the points, right? So you will get the classification separated out. So this is called as linear discriminant analysis. So now you may ask the question. So many machine learning algorithms, right? For example, I have 4 classes. Let us say the classes are alpha, beta, gamma, delta. Correct? So you may expect your LDA should give, let us say, alpha i's. That's one class. And another one is, let us say, beta j, second class. So it may give gamma k, the third class, right? And then you have delta z, the fourth class, right? But are you getting 100% accuracy in all the, maybe I'll focus on one node. It is obvious for all the other nodes. Okay. So are you getting 100% accuracy for all the cases? No. Because what happens, sometimes you may get the anomaly. Let us say 2 beta points, 1 gamma point, right? And then 2, 3 delta points, right? I write a delta I, right? So you may get 95% accuracy for alpha or 96% accuracy for beta. So how to achieve 100%? So what I am going to do, I'll use the same algorithm, right? Again, for the second iteration, I am trying to get, let us say, the improved accuracy for alpha, improved accuracy for beta, right? Improved accuracy for delta, and improved accuracy for gamma. So when you do this process, let us say you are reaching till leaf node, right? Now you are trying for LDA tree. So this is a tree. Your tree looks like this. You are trying for LDA tree. Your tree will look like this. So till you reach the leaf node, so what you have to do? You try to put the classification separately. So I'm keep on doing. At one point of time, the alpha that you are getting, so it may be 99% accurate. Maybe very few beta, very few gamma you are getting. So that means you have improved from when you are using only LDA with one iteration, you will get 95% accuracy. Whereas if I grow as a tree, my accuracy may go for 99 to 100%. So you are calculating this. You are calculating. You are doing your algorithm based on this. So we call this as LDA tree-based classifier. So we'll go back to our original problem. So suppose here you are seeing a person is running, right? So what we are going to do, we are going to have a training. You have to train the data. So and then you have to find out the you have to find out the fill out, that means region of interest, and then you have to find out the skeleton. After finding out the skeleton, your features are like this. So this is your extracted features. The one you are seeing here, this is your extracted feature. So that means I'm calculating in each sector. Assume that I have 8 sectors and 9 frames. So totally I will have 72 attributes. Right? So these 72 attributes, let us say if I plot it, it will be like this. So this is a feature extraction for, let us say, running sequence. Similarly, you have to extract features for all the other classes. Right? The classes may go like this. So the classes may go like this. The hang on bar, walking, running, punching, collapsing, knockout, smash, right? So all they are considered as different class in a database called virtual human action seal out database. So now we have to extract the features. We have to train the model, right? For different classes, this is the training data, right? So this is the training data and we are getting the corresponding features, right? So now we'll try for the testing one. Assume that we are using some 6 actors and 12 camera views, right? So your single shot LDA will give several mismatches, several misclassification. That's a single shot LDA. Whereas the proposed algorithm, right? So here you can see proposed in the sense when you are going for LDA tree. Proposed one is nothing but LDA tree. So LDA tree based classifier, if you look at the misclassification, almost 0 or 1 or 2. Whereas here, the single shot, only one time you are doing your LDA. So for this particular class, the misclassification score is going to 5. So the number of score is increasing means your mismatch is more. So now you can see here. So this is the common area of the parking lot after mosaic the image. And we'll go for the experimental results. Right? That means testing data. We are going for testing. So here a person is running, walking, 2 arm up, 1 arm up, and then sitting posture. We are getting the corresponding region of interest, and then we are calculating the skeleton, and this is the extracted feature. So now I have a classifier called LDA tree. I know how to classify based on these features. So the accuracy you are getting 98.5% if you use LDA tree based. Otherwise, if you are stopping the algorithm in a single iteration, you are getting 95.8%. And here you are seeing the confusion matrix. For sitting posture, right? How far it is true. So the main diagonal is suggesting, right? The main diagonal is saying this one, right? What is the percentage? One is indicating 100% accurate. So this is 98% accurate, 96, and so on. Right? Similarly for single shot LDA. So we are getting LDA tree-based algorithm 98.5% accurate. So we have increased from 95.8 to 98.5. So you may ask the question. So right now we are in the deep learning era, right? So can we increase the accuracy? Yes, if you apply the deep learning algorithm, for example, here you have the University of Texas dataset for the human action. So here, a person in a video, a person is doing several actions: throw, push, walk, right? These are all the actions. So now the input is RGB video, gyroscope sensor data, and the skeleton data, right? Video, the sensor data in the sense assume that the person is wearing some watch, smartwatch, so which will generate the data. And similarly, we know how to calculate the skeleton. right? So given video data, first we find the stack dense flow difference image, SDFDS, right? So the video is being converted into 2D data. Image data is nothing but the 2D, right? So we train this 2D data by two-dimensional convolutional neural network. Similarly, 1D data should be trained using one-dimensional convolutional neural network. So 1D data is nothing but your smartwatch, etc. Right? The data that you are getting is from the smartwatch or any wearable device. Right? So now, if you look at in the deep learning architecture, so the first one you are seeing is the input layer. Right? So this is your input layer. So in the input layer, you have the one-dimensional data from the sensor, and from the video we calculate this stack dense flow difference image. This is a 2D. So this is a 1D data, this is a 2D data, and we calculate and we have a 3D skeleton data, right? So each are in different dimension. We use one-dimensional convolutional neural network for 1D data, and two-dimensional convolutional neural network for 2D data, and recurrent neural network for the 3D data. So we are training in the hidden layer. So this is your hidden layer. And then since all the dimensions are in different, we have to fuse to the common dimension. And then it will be separated out. The classes will be, so these are the different classes. Waving, clapping, throwing, squat, running, kicking, right? All these are classes. So this work appeared in the Journal of Ambient Intelligence and Humanized Computing. And this work was my former PhD student, Dr. Javed Imran. And in this case, you can see the accuracy is 97.91%. Similarly, we have another data set called multimodal egocentric activity data set. So here, this is called as ambulation, right? So this is called ambulation. Ambulation means, for example, what is meant by multimodal egocentric? Assume that a person cannot see the world, right? Assume that a person cannot see this world. So in that case, let us fix a camera in the forehead of the person. Right? Camera in the forehead of the person. And then this camera is connected with the device, mobile or the smart device like a watch, etc. Right? Wearable device. So now, suppose the person, as I already said, the person cannot see the world. Right? So this will work like, right? For example, this image is appearing in the camera. So that will tell you are in a zebra cross, so you can walk. And you are near upstairs, right? You are walking upstairs. You are walking downstairs. Or suppose a person is near a restaurant and the camera is capturing some food like idli, dosa, etc. Right? So it can suggest, I mean, you are near restaurant. Right? So like this, riding elevator down, riding escalator up, sitting. So all these postures or all these are called as the ambulation. Right? Similarly, the daily activities like eating, drinking, texting, making a phone call. So they are all like a daily activities. Similarly, office work, right? So similarly, in the ground, what are all the different exercises, right? So they are all called multimodal egocentric activity data set, where this application is purely helpful for a person who cannot see the world. So the camera is connected with the head-mounted camera, right? In the head, we are fixing the camera. So this head-mounted camera is connected with, let us say, a mobile. All right. So this mobile will trigger. For example, after seeing this image in the video, okay, you are near metro, right? You are near restaurant. You are near lift. right? So you can go upstairs. So like all these text information, text or speech information will be triggered to the person who cannot see the board. Right? How do you solve the problem? So using deep learning algorithm, right? So the input source is Google Glass, kind of the head-mounted camera, right? So they are capturing the video data set, and from the video we are calculating, let us say, approximate dynamic image called ADI and stack difference image called SDI. So once you calculate these, right? So you have a video is a 3D. So from the 3D, you are computing the 2D images, ADI and SDI, right? Approximate difference image and stack difference image. So 2D convolutional neural network is useful to train these data. All right. Similarly, a person, the same person is wearing the smart watches, a smart device. All right. So we use one-dimensional convolutional neural network in all the cases to train these data. So since the data is of different dimension, we have to fuse these data to get the output. So these are all different classes. So this work appeared in Indian Conference on Vision, Graphics and Image Processing. So in this case, we got the accuracy up to 86.5%. I'll take some water, little break, and then we'll start from the infrared action recognition.
Yes, sir. If you all have any query, please mention it in the chat box.
Okay, so the next application is infrared action recognition. So here you can see some of the actions are happening during night, right? For example, we have simulated this action in IIT Roorkee campus, right? Where we have seen a person can carry a gun, pointing a gun, fighting, kicking, hugging, punching. So if all these activities happen, can this trigger to the security person? Right? Suppose you have an infrared camera, let us say in the campus, and if any unwanted things happen, so can it trigger the security person? Yeah, that is what the idea of this work. And we again use the deep learning algorithm. So here you can see the video is the input. So from the video, we will find the 2D SDFDI and SSDI. SDFDI stands for Stack Dense Flow Difference Image, and SSDI stands for Stack Saliency Difference Image. So locally and globally, we are finding. So this will be your 2D. So we use convolutional neural network to train the model. Convolutional neural network and BiLST, right? CNN and the combination of BiLST. So here for the local SDFDI and local SSDI, we use CNN with BiLSTM. For the global SDFDI, we use convolutional neural network. So fuse all the data together and get the output. Right. So this work. So this is a hidden layer. The input layer is one dimension. Video. Video data is the input, and then we find the 2D image. Yes, these are all will be in the hidden layer, and in the output layer, the classes will be there. So this work appeared in the infrared physics and technology. And accuracy point of view, since it is a night vision, so 75.17% accuracy we are getting. So this is all about your video analytics problem. We'll have another half an hour. Yeah, I can easily finish. So the next application is sign language recognition. So in IIT Roorkee, we have a school called Anushruti. So in Anushruti, right, the children cannot talk or right, so cannot talk or hear. So in this case, they will communicate each other with some sign, right? So for example, here you are seeing the American Sign Language. For A to Z, you have different signs. So now we have 26 classes, right? So these 26 classes assume that I am using, so let us say, right, for some complicated background. For example, here the hand, face, and the background. So right, they are all same, right? So in these cases, what exactly she wants to communicate? She wants to communicate, right? So my main idea here is assume that I use various pre-processing techniques, right? So to find the region of interest. For example, the face and the hand color may be same, right? So we use some morphological operations or various pre-processing algorithms in image processing, right? So I will come up with the region of interest like this. So this will be my region of interest now, right? So once I find this, assume that I start the language with the preliminary alphabetical ABCD. So among this, I can find what is the 26 classes. Correct. So initially we tested with the various algorithms like SURF1 support vector machine, wavelet and support vector machine, or wavelet with linear discrete analysis. So our idea is to increase the accuracy, get more and more accurate value. So that means indirectly we are telling the machine learn ABCD up to Z. So once you have been trained with alphabets, you go for words, right? You go for, let us say, sentences. You go for, let us say, essay type, right? So the idea here is we are putting a mobile in front of those students, right? Those who cannot talk or hear, right? And whatever action they are doing, we are placing a mobile in front of them, and your mobile will convert what action they have done to speech, right? So that we will listen, and then vice versa, right? Problem is not one way, vice versa. I will speak, and then the speech will go as a right action to them. So in that way, one to one, we will get benefited. That is what the idea of this application. So we have several data set like English, so German data set, right? German finger spelling data set. So this is the right action recognition data set. Right, so we have to do right the feature extraction, classification. So here we have used algorithms like a random forest, support vector machine, right? All these algorithms have been used for classification. Now you know how to do feature selection, how to do feature extraction, right? I can now talk about simply, right? We use a random forest for classification or support vector machine for the classification, right? So in the German finger spelling, unlike your A to Z, you have several other letters, right? So total it will be like 35 basic characters. All right. So the accuracy, the support vector machine and random forest we are using for 30 classes and 35 classes, we get accuracy 76, 73, something like that, right? So you may ask the question, can we use deep learning? Can we use deep learning algorithms to increase the security, to increase the accuracy? Yes, you can. For example, for the Argentinian sign language recognition, we use a deep learning algorithm. So you can see in the video, they use the gloves, right? Gloves of different colors. So that will give additional features. So now we use the This is the input. So here we use RGB or depth video as the input. We calculate MHI called motion history image. We calculate dynamic image. We also calculate RGB motion image. We call it as RGB MI. And then extract the features based on mobile net convolutional neural. I'm extracting the features based on the deep learning. And then use the classic machine learning algorithm for the classification. So KELM, kernel-based extreme learning machine for the classification. So you can do like that, combination of deep learning and machine learning. Right? So what is the output you are getting? So here, this is your video, and then I calculate MHI, DI, and RGB MI. Those I have explained in the previous slide. So the hidden layer, we use convolution net to find out the features, extracting the features, and then use KELM for the classification. So that will give a different class. So this is what the combination of machine learning and deep learning architecture. So this work appeared in the visual computer. And the accuracy we got 97.81%. And also during night, right? Suppose they want to communicate during night. Is it possible? Yes, we have done some work on thermal data set. So now the main advantage of the sign language recognition, you can think of the Indian scenario. The Indian scenario, you have several languages, right? For example, Tamil, Malayalam, Telugu, Punjabi, Assami. So we have so many languages, right? So each problem will have a separate PhD, right? Even whatever the algorithms the researchers have used for English, German, or Argentinian, this is what we focus because we have the data set. And if you think, right, Tamil, for example, the language that I speak, Tamil, it has got 247 characters, 18 into 12 basic characters. Total 246 plus one special character, 247 characters. So unlike your English, it has only 26 characters. All right, so that itself is a very good problem. If you classify these 247 characters in Tamil, it's a very good problem. And then you go for the words, right? And then you go for the sentences. Then go for the essay type, right? For example, somebody speaking, let us say for half an hour, right? Somebody doing action for half an hour. Can it be converted into the language? So you can think of, right? So we have several languages. Telugu is there, Malayalam is there, right? Hindi is there. So you can think of those who are starting with a PhD, those are right, and then you want to work on machine learning, deep learning, and data science. So you can think of these kind of problems, right? So this is in fact, it is applicable to the Indian scenario. And I have not found many papers on these areas, those who have focused on the regional languages. Right? So we have some other applications like a kinship verification. Right? So here your machine will tell, right? Suppose the images are given like this. Assume that the images are like a father-daughter, father-son, mother-daughter, and mother-son. All right. So in this case, can your algorithm say that they are related or not? Right. So for this, we have taken the iris. That means the eye image. So you can take any features, eye, nose, right, like your lips, right. So here, based on the eye features, it's only a feature extraction problem. So that will classify whether they are related in this relation. Father, son, father, daughter, mother, son, and mother. Right. So the image will be given. These two are the input. Assume that these two are the input. And period color in the sense I am finding the Irish image. Irish means their eyes. Based on the eyes, my output will tell as they are related. And how they are related, whether the father, mother, daughter, mother, son, and mother, daughter. So this work appeared in computer vision and image understanding, right? So the idea here is, so this is one of my PhD students' work. He has taken his image and his daughter's image, right? So pedioculus, that's eye image, and then calculate local tetra pattern, right? Also study with the metric called BNR or ML, all right? So calculate the score. Based on extracting the features, calculate the score. So calculate the score for father, calculate the score for a daughter, right? And then, because these are all based on the eye features, and then whichever is matching, right? If the score, let us say father is getting a score 87 and daughter is scoring near 80 to 85, all right? So they are related to each other. So this is how in this paper, so he has proposed. So that is called evaluation of pediocular features or kinship verification. So this is the algorithm. Extracting a feature from based on the features, is it possible to do the matching? That is what the idea. And these are all some of the results. So you can see that, right? So we achieved up to 77.05% for two different data sets. So we have got up to 77.05%. And almost to the last part of my work. So it's unsupervised learning, right? What do you mean by unsupervised learning? As I gave an example, right? The same robo and fruit example. So the robo can classify the fruits without any prior information, right? We are not giving any, we are not doing any, right? We are not doing any station. All of you, please mute your mic. So now, if you look at, in this case, here you can see a pair is dancing, right? A pair is dancing. Assume that I have 5 minutes video. Now the problem is, can we generate based on the steps? Okay, so can we generate next 5 minutes? That is what the idea. So the blue in color is indicating here given video, right? We are extracting a skeleton like this. And from here, using the deep recurrent network, right? Deep recurrent neural network. So is it possible? The red in color is indicating that after time t, let us say till 5 minutes. So can I generate 6 minutes, 7th minute, 8th minute? What would have happened? Right? Not only minutes, seconds. Right? What exactly can I predict? Right? So the idea is the prediction generation. Right? So that is what the task, and it has got a several applications: virtual reality, right? Action recognition, surveillance, healthcare. So all these you can find the application. So this is the proposed architecture for the case of deep recurrent network. Maybe you can look at this paper, right? How exactly it is being defined, right? I'm just giving application here, and for a technical results, you can refer the paper which was appeared in International Conference on Image Processing. So here you can see that. So the accurate LSTM model was used by Zhou and others. You can see this is the given skeleton, whereas the generated data is the elongated one, not so good, right? And you can see the animation, right, which is not so good. And then what we have done, the same method with the post embedding. The post embedding results were slightly better, not very good, but slightly better. And you can see the animation also, still the elongated hands and legs. Whereas we propose an algorithm, variational recurrent neural network, right? So this is the input, and you can see, right? And you can also see the animation, how smooth it is. So this is a generated one. So this is a given for, let us say, 5 minutes, and we have generated for the next 5 minutes. So now there are researchers working on how to find out the complete 3D, right, based on the skeleton, right? That is that those are all right. The next part of work. So here we are, what we are doing from the given 2D data, the given data for, let us say, some t is equal to t naught seconds. So we are generating after t naught, let us say next 5 minutes, 10 minutes. So is it possible to generate? And if you look at, when you compare, right, and moreover the second one is slightly slower, right? First one is the elongated one, whereas the third one, the result that we obtain, you can see the animation. It is very faster, and you can also see there's no much, in fact, no elongation of the hands and legs. Right? So this is how we improve with the help of the deep recurrent networks. So that is one application. And the last part of my talk is the combination of cloud and convolutional neural network, right? So both are very fascinating terms, right? The cloud and the convolutional neural network, right? So yeah, so what we can do, suppose I am dealing the data, right? The video analytics data. For example, I'll just go there and then I'll talk about all these. Suppose you are analyzing this data, the leftmost one, use the pen. Suppose assume that you are analyzing this data, right? The image, the video, right? You're taking a snapshot, it's an image. So now assume that I am the person and you are analyzing my video. I may not like this, right? And I'm usual whatever talk that so far I have done, I am calculating MHI, I'm calculating, right, all the depth, right? Whereas you some people may not like. So what I can do? I can do the video or image obfuscation. So many videos, the same video can be represented like this, right? So many video you can see that in the news, right? So they don't want to show the person, right? So they obfuscate. The technical term is called obfuscate, the obfuscation of image. So now the problem is, suppose you are given, let us say, 30 minutes video like this. Your entire video look like this. So now the challenge is, can I do the action? Right? Can I find out the human action? Can I solve the problem of human action recognition? Right? So here you can see this is the original image. I use a block size 2x2. So still some visibility is there. 4x4, some visibility is there. So if I go like this, 16x16, slightly better. You are not seeing the person at all. 32x32, much better. I completely obfuscate the person. So now I place these data, right? This data into my cloud, and then I can do the same action recognition algorithm, right? So if I use the 112, the 2x2 block, 112x112 image, the accuracy of my algorithm is 89.3. Whereas if I use the 7x7 image, that means 32x32 block, my accuracy is 83.022. Yeah, obviously it will be slightly lesser because if you look at this data, right, and this data, both are right completely different. So the accuracy may go down. So the main advantage is right here you can find out several applications where the data has been placed in the cloud like this. So even somebody hack it, one cannot find what exactly it is. Whereas if I am placing my data in the cloud, if I place the data in the cloud like this, so then I will have a problem, right? If I place the data in the cloud like this, right, the privacy is being lost, right? So assume that I am working on my action recognition problem, the usual one, right? The usual data, right? The depth or RGB image, I calculate MHI and the depth, and then use some mobile net for training and get the output. So now the challenge is the obfuscated image. All right. So this work, one of my PhD students, Amitesh Singh Rajput, right now he's in BITS Pilani. He worked on privacy preserving algorithm using cloud. And you have seen several Dr. Javed Imran's work on convolutional neural network. So the combination, right? Both the students, when they work for the PhD, they combine the idea for putting the obfuscated image in the cloud, and then can we do this action recognition problem, right? So we were successful, and this work appeared in Expert Systems with Applications. Right, and the accuracy is 83.02%. So you can improve, right? So we have seen, I have talked about several applications, starting from brain-computer interface, action recognition, activity recognition, sign language recognition, right? Periocular classification, right? And then how we can combine, or how we can do for unsupervised algorithms, right? For example, the generation of the skeletons. Last one we have seen the combination of cloud and convolutional neural networks applications, right? So now, if you have the questions, any questions, happy to answer.
Sir, we have one query from Dr. Gagandeep Arora. And his query is, do we have to record brain signals for individual events, then keep it in database?
Yeah, it is depending on, right, the applications. Yes, you have to. You have to. So either keep it as a video or it as a image. Or the signal. I'm sorry. I'm talking about the signal. Sorry. So the signal, yes, you have to one-dimensional signal. Yes, you have to. Yes, you have to do that for the individual. That's a good question. Not sure. There is another question, true or false.
Any other query from participants?
Share your presentation on my email. Yeah, I will share your PPT. I'll share my PPT.
So we don't have any other query.
Okay, no more questions. Okay, fine. Yeah. So I acknowledge, since we have or we are doing the projects for DRDO, SCRB, METI, Samsung. Also thank IIT Roorkee for that instrument, the EEG signal, EEG instrument, and all members of Machine Vision Lab, PS department, and Artificial Intelligence and Data Science Center. And this is my lab website. So you can download several data sets, right? And the next one is my website, and you can also find my email ID. So thank you all.
Thank you so much, sir,
Thank
for
you,
such an informative session.
Yeah,
I'm certain that this session will help in guiding our attendees.
Sure.
Thank you so much.
Thank you all. So thank you all. Thank you. Nidhi is not here, right?
Yes, sir. Please don't.
Okay.
She's
Not a
not.
problem. Thank you. Thank you. I'm leaving.
Thank you, sir. Okay, thank you everyone for attending the sessions. Thank you.